Hello and welcome to the Embergen introduction tutorial. In this tutorial, we will get well acquainted with this very fun and powerful software, and after going through all the lessons, you should feel extremely confident using most of its features. But what is Embergen anyway? Embergen is a GPU-based real-time fluid simulation and rendering software. It is also capable of simulating millions of particles in real time. Simply put, it is an extremely fast software that will help you create effects like fire, smoke, explosions, pixie dust, and a great number of very realistic and also fantastic effects for the video game and the visual effects industry. Now, before we dive into the fun stuff, I want to explain a bit of theory and technical information that will be of great use for simulating realistic fluids, not only within Embergen, but also any fluid simulation software that you might use. That being said, let's take a look at these principles. First of all, let's talk about combustion and how does it work. Because most of the time within Embergen, we will be trying to reproduce realistic effects that are based on the combustion model. So, combustion is a chemical reaction that produces heat and light. The most common form of combustion is fire. Most forms of combustion happen when the gas oxygen or oxidizer joins with another substance that we call fuel. Combustion begins when the fuel reaches a temperature called its ignition point. At this temperature, oxygen combines with the substance fast enough to produce a flame. As a result of the combustion, exhausts are created, like smoke and soot, and heat is released. We can control or stop the combustion process by controlling the amount of fuel available, the amount of oxygen available, or the source of heat. To summarize, for combustion to occur, three things must be present: a source of oxygen, fuel to be burned, and a source of heat. Now, within Embergen, the oxygen will be present in the entire grid or domain, and we will talk about this in a moment. But in most cases, you will need to create your own fuel and a source of heat to control your effects. Of course, we will take a look at practical effects, but keep these concepts in mind because most of the time, what we want to generate is either fire or smoke, and all of these have to do with the combustion model that we just described. Now that we understand how combustion works in real life, let's take a look at a practical example within Embergen. For now, don't worry about the interface, the tools, the parameters. Let's just take a look at the principles that we just explained and see how they are applied within Embergen. Now, here on the viewport, we can see a rectangle. This is what's called a domain, or in some other programs, the grid, where the simulation is generated. Now, if I press play to the simulation, you'll notice a blue line on the bottom. This is representing our fuel. Now, the red sphere on the top left corner represents a heat source. Notice how if I move the sphere downward towards the fuel, it will start the combustion reaction and fire will be generated, and from this fire, smoke will also be generated. And thus, we will have more temperature emitted. Now, this is very important to consider because this will let us control our simulation in a very precise way. For example, let me reset the simulation. Let's bring up the fuel source, or actually the heat source. Now let's reduce the fuel emission. So I will click on the emitter volume that is generating the fuel. And under emission, I will reduce the fuel rate to about 50. Now notice we don't have enough fuel, but let's see what happens. I'll bring down the heat source. And the flame is exhausting pretty fast. So let's increase now the fuel. And eventually we will have enough fuel to generate a flame. Now let's do the opposite. Let's reduce the amount of heat that we're generating. I will select the heat emitter And under emission, I will reduce the temperature to about 100. And bring the sphere closer to the fuel. So the heat is not enough to create the flame. Let's now increase the temperature. And eventually the combustion reaction will be generated. One last piece of technical information that I want to talk about before we dive into Embergen is the simulation domain and the voxels. We all know that 2D images, like pictures, renders, or illustrations, are made up of hundreds or even thousands of tiny squares that can have different color variations. These small squares are called pixels. Of course, the more pixels we have in an image, the more detail the image can have. So the more pixels we have overall in an image, the more resolution the image will have. Similarly, a fluid simulation domain is made up of thousands or even millions of tiny cubes called voxels. In the same way that a 2D image can have different resolutions, a 3D domain can also have different amount of voxels or resolution. In other words, detail or fidelity. Now, most of the times, these voxels can contain fuel, temperature, flame, density, and velocity. They can also contain color and other useful information, but these 5 are the main types of data that we will be managing. Now, in a fluid simulation, the amount of voxels that we can calculate depends on our graphics card memory. The more memory you have in your graphics card, the larger domains you will be able to simulate, and the more detail your effects will be able to have. Just consider that a domain having 3 dimensions can very easily and rapidly increase the amount of total voxels that the domain can contain. With time, you will learn how much data your computer can handle, and also Embergen has some very useful tools to let us know how large our domain can be created. For now, keep this information in your back pocket because you may need to reference it later. I think at this point, we're ready to dive into Embergen and start creating some cool effects. We are now within Embergen and ready to start. One final note, I'm currently using Embergen 1.1, and if you can, please download this version because it has a couple of nice improvements over Embergen 1.0. That being said, Embergen is a relatively friendly software to learn. And the reason I say this is that Embergen has a couple of very interesting and user-friendly implementations that will help you to start using the software in a very fast way. So first of all, if you take a look at the home screen, you'll notice we have a couple of tabs on the top left corner. The first one is Home, where you will see some recent projects. If you've opened some projects, you will see them here. We also have some new videos that have been released. Some of them may be tutorials or podcasts, news on new releases, and so on. Another tab has a couple of tutorials, quite basic, but still, if this is your first approach with Embergen, they might be worth watching. And one of the most important to me is the Presets tab. The Presets has a whole lot of examples that you can open, study, and deconstruct to really understand how the effect was made. To me, these presets are extremely powerful, extremely useful, and we will be exploring some of these in future lessons. If you have any questions, you can always open the Discord page or the forums, and most of the time you'll find people trying to help on the forums. Finally, if you take a look on the bottom left, you have a button to create a new project and open any project that you have within your hard drives. Okay, so since we're going to start from scratch, let's click here on the New Project button. And this is one other thing that I was mentioning. Even if you're creating a new file, Embergen provides you a preset of a working fire, and it's a very decent looking fire simulation with some smoke going on. One final thing that I want to show you before moving on with the user interface is we can select every single node and delete these nodes, and Embergen will suggest how to start. And what I mean is, even if you have absolutely no clue of what to do, Embergen will suggest step by step what needs to be created in order for you to have a functional simulation. For example, it says here, create a simulation node, and I can do that by right-clicking on the node graph and typing simulation, clicking on the simulation node. Then Embergen will suggest to create a scene node. I will do the same, right-click, type scene. Then Embergen is suggesting to create a shading node. And let me show you something even cooler. I can click, for example, on shading and drag, and it will suggest what type of node I need to create. So even here, I have a lot of help from Embergen. Now I need to connect either a volume or particle pin on the scene node, so I can click and drag here. And finally, we need to connect a lighting, so I can click on lights, drag, and select, for example, a spotlight, point light, ambient, or directional. And now we're ready to start adding emitters, collision objects, or more detailed stuff. Of course, we will be looking into all these nodes on detail, but I just wanted to bring this notion home that Embergen is relatively easy to use because it's always giving you some help onto how to create your scenes. Let's now talk about Embergen's user interface and its main functions. So let me go to the File menu, click on New Project, and of course I don't need to save this project. Again, we're back with the default fire simulation. Of course, we have a huge amount of nodes here, but don't worry, we will understand all of them in due time. First of all, I want to show you the viewport. In this case, the scene window. You can click and drag to rotate or orbit around your scene. You can use the middle wheel button to zoom in and out, or you can right-click and drag to turn the camera around. Finally, you can middle-click and drag to pan the viewport. Now, something that I really like about Embergen is this information window. So there's an overlay on the top right corner of your viewport that's indicating the bounds of the simulation, the total number of voxels that you have within, your image resolution, simulation speed, render times, some other important information, but probably the most important one is this VRAM information. So notice how I have a number 2.3 of 23.8 gigabytes. So what this means is that my computer has almost 24 gigabytes available, and the current simulation is taking 2.3 gigabytes of those 24. This information is very important because you always want to keep your simulation before your VRAM cap. If you go above that value, most probably Embergen will crash. In any case, you should always keep this information handy. Of course, we can turn this overlay off. So you can go to View menu and turn off the stats. Or you can also press Shift S to turn them back on again. That being said, you will also have a couple of tools here on the viewport. One tool to move your objects around. Another one to rotate. And finally, one to scale the objects. Of course, on the top row, you'll have a main menu with some file options, edit options, simulations, settings, and your account options. But when you're working with Embergen, most of the time you will be working with menus either on the node graph, the timeline, or even the node details pane. Okay, so let's take a quick look at the timeline. So here you can reset the simulation by clicking on this arrow. You can also press the R key, which I prefer. Of course, you can pause the simulation, or you can advance by keyframes. Right now we don't have any keyframes, but when we start creating animation, we will be able to do that. And one very important shortcut within the timeline is pressing the Z key will allow you to step through your simulation. So here I can step through frame by frame. Now within the timeline, you can control and middle wheel zoom in and out, or you can also click and drag this gray bar on top to move the time frame forward or backward. Now, one important thing, since Embergen is simulating in real time, you cannot really scrub the viewport. You can either reset and play, or step your simulation with the C key, as we already mentioned. Okay, now the node graph on the top right will be where you will construct your simulation based on nodes that will be connected between each other. So here you can middle click and drag to pan the window. You can wheel in and out to zoom in or out. And you can right click to open this node menu. So if you want to create a new node, you will always right click on the node graph and select from the list. For example, let's create a shape. Finally, on the bottom right, you will have the node details. Think of these as the parameter window of Embergen. Whatever node that you have selected on the node graph will reflect its parameters on the node details window. Let's now go through the anatomy of an Embergen scene. And for that, I'll go to the New Project button. And I know this is a bit overwhelming. So what I like to do, especially when I'm starting to learn a new software, is I try to understand its smaller pieces from basic to complex. So let's do that now. I will select all the nodes on the node graph. So I'll click and drag. And once they are selected, I will click on the delete button. I will now create all the nodes needed to have a fully functional simulation. Now, don't worry, we will understand how these nodes work in later lessons. For now, I just want you to construct a working simulation so you understand which nodes are needed, which might be optional, and which of these are mandatory. So the first thing I always like to do is create a scene node. And the reason is because everything will be eventually connected to this node. So I will right click on the node graph and type scene, create a node. Now Embergen is suggesting to create a simulation node. So let's do that. I will create a simulation node. And then notice how the simulation has a volume and particle output. These will be connected to the scene. Now, here you might want to take a note. One thing that I always do is click and drag from the volume output and create a volume processing node. So let's connect the output of this volume processing node to the volume input of the scene node. Now let's create a shading node, and you can either create the shading node and then connect it to the scene as suggested by Embergen, or you can do it the other way around, which I find easier. You can click from the scene node, the shading input, drag, and then just select the shading node, and they will be connected automatically. Okay, and finally, Embergen is suggesting to create a light and connect this one to the shading node. So I will click on the lights on the shading node input. And in this case, I will create a directional light. Now notice that we have a domain created. You can see the cube on the viewport. We can also see this light. And since it's a directional light, the position doesn't really matter, just the orientation of the light. And even though we have a simulation node and a scene node, we still don't see any fire or smoke. For that, we need what's called an emitter. And if you take a look at the simulation node, you will see an emitter's input. I will click on this input and drag outward to create a volume emitter. Now, the volume emitter by itself is not enough. We need to create a shape that will emit the volume itself. So let's create a shape. I will right click on the node graph, go to shape and create a primitive. Primitives can be spheres, can be cubes or cylinders. So I will connect this shape to the shape input of the emitter volume. And now we have a combustion simulation working and everything we need to tweak this simulation. So as you can see, it wasn't hard. It was actually extremely simple to create our first simulation. Of course, as I mentioned before, we will go through all these nodes so you can eventually have a huge amount of control. Probably the most important node, or at least one of the nodes that you will spend the most time tweaking, is the simulation node. The simulation node has a great number of parameters, and one of the most important is the domain group. If you take a look at this domain tab, you will have the voxel count, the voxel size, and the upscaling. These three together control how much detail your simulation can have. So first of all, let's take a look at the voxel count. This is literally how many voxels wide, deep, and height your domain grid will have. So of course, if you increase the voxel count horizontally, say to 256, press enter, and then click on apply new resolution, you will have much more resolution within your domain. So notice how we currently have 8 million voxels, while before scaling on X, we had pretty much half of that. Let's again change the X value to 128, press enter, and remember to apply size changes. You always need to click on apply new resolution. And of course, now we have 4 million voxels in our domain. Then we have the actual voxel size. And notice how the physical size of the domain is also dependent on this size. For example, if I duplicate the voxel size to 0.2, I'll click in apply new resolution. The grid appears to be twice as large, and it actually is. But even if the domain is larger, we still have those same 4 million voxels because the amount of voxels within the domain is still the same. We're just changing the size of the voxels. Now, what if I like the size of this domain, but I want more resolution? I would need to decrease the voxel size to half, for example, 0.1, while increasing the total amount of voxels to twice as much. And one interesting thing about the Embergen interface, you can always do basic math operations with your parameters. For example, I can multiply 128 times 2 and press enter, and that would give me 256 voxels. So I will do the same in Y. And in C. I will apply the new resolution. And notice how the domain size is exactly the same, but now we have much more resolution. And also notice how the simulation is now slower. So of course, the higher the resolution, the slower the simulation will be. So at this point, this is not a real-time simulation, but consider we have a pretty high resolution. Now we have 33 million voxels, which is quite high. Now, one very interesting tool is the upscaling tool. Let me bring back all of the values to its default. And if we want to increase the resolution, instead of doing the math and converting the voxel size and multiplying the voxel count, we can use this upscaling feature. For example, notice we're back to the 4 million voxels. Say I want to keep this exact domain size, but I want twice the resolution. I can go to upscaling times 2, click apply new resolution. And again, I'm back to 33 million, but the domain size is exactly the same. So this is probably an easier approach to up-res your simulation once you're happy with the results. And Embergen is very good with this methodology. Usually you can prototype your effects very fast, pretty much real time. And once you're happy with the result, you can upscale the resolution for a final render or export. Now that we understand the domain size parameters, let's talk about the time control. This is also a very important concept within a simulation. So if I click on the time control tab, you'll notice that we have 3 parameters: looping mode, free simulation, and Timestep. And of all these 3, Timestep is the most important one to understand. So notice how we currently have a value of 60 Hertz. And what this means is in every second, we will have 60 iterations or 60 steps of the simulation. Let me reset the simulation. Actually, I will pause it, reset, and I will step through the simulation using the C key. So notice how by the time we're on frame 15, the time is 0.25 seconds. So if we keep moving forward, by the time we're on frame 30, the time is exactly 0.5 seconds. And as you will expect by now, if we keep moving forward, by the time we have reached 60 steps, we're exactly on the 1 second mark. Just keep these values in mind because they will become very important once we start thinking about how much time we want the simulation to span. Now, I wanted to explain the time control and the domain sizes before we actually start looking into the rest of the parameters, because I consider these 2 very important and will be used in every single project. Now, Embergen, being a real-time simulation software, is much more fun to learn with practical examples and actually tweaking the parameters in real time. And that's exactly what I want to do. I will explain each of these nodes while creating a practical example and tweaking the parameters in real time so we really understand how they work and how they influence our simulations. Now that we've talked about these very important topics, domain size or resolution, and Timestep, let's talk about another very important topic, which is emitters. So let's start opening a new project. I will remove every single node that we have. And as usual, let's create our own scene. Hopefully at this point, you're more comfortable creating your scenes from scratch. So let's start by creating a scene. I will also create a simulation. And I will connect both volume and particles to the scene. And remember, I recommended using a volume processing. So I'll click and drag from the volume output in the simulation node and click on the volume processing to create the node. And connect the volume output of the volume processing to the volume input of the scene. Now let's create our shading node. So I'll click and drag from the shading input of the scene node and create a shading node. And finally, let's create a light. So I'll click and drag from the light input and create a directional light. Now, on previous videos, we briefly created an emitter just so I could explain some related topics. But in this video, we will see the emission in detail. Well, actually, we will talk about the volume emitters specifically, and we'll talk about the particles emitter in future tutorials. So to create an emitter, the easiest way is on the simulation node, click on the emitter's input, drag, and select the type of emitter you want to create. In this case, we'll create a volume emitter. Now, you will notice that nothing really happened because in the end, an emitter object also needs a shape to work. You can think of the shape of the actual object that will be emitting either fuel, temperature, or smoke. So let's click and drag from the shape input. And for now, we'll create a shape primitive. We will go more in depth into the shapes in next videos as well. So I'll click on shape primitive. And notice how we now have a flame and some smoke being emitted. So make sure to click on the emitter volume. And you'll notice how this node has a couple of properties. And first of all, what I'm going to do is talk about the visuals. And the reason I do this is just for you to be able to see the emitter in the viewport. But don't worry, we will talk about the rest of the parameters in a moment. So click on the Visuals tab and make sure to click on Show Emitter. Now, as you can see, the default shape that we created here is a sphere. So I will select the shape primitive and move it up just a little bit so we're able to see the entire sphere. And again, I'll click on the emitter volume. And let's finish taking a look at these visuals properties. So the emitter color will let you change the color of the emitter as its name suggests. Usually there's no much need to change this because normally you don't want to render the emitter shape. There might be some exceptions for this, but in general, this is just a visualization tool while you're working with your simulations. So for now, I will just change the color to some kind of green and close the color picker. Now, an interesting thing is the emit light. Notice how emit light is on. For a moment, I will turn off the show emitter option and I will increase the emissive light intensity. So you will notice now we get a little bit of a glow around the emitter. And also, if we had any smoke nearby or geometry surfaces, this would also emit some light on those objects. So let's increase the emissive light intensity a bit more. Let's go with 250 or even 1000. And you can also change the color of this light. So let's try with a blue tint. And this can be very cool to generate some magic or stylized effects. Now, with this out of the way, let's turn off the emit light. And let's click on Show Emitter once again. And now let's go back to the Activity tab and check out the rest of the parameters. So, first of all, you have what's called the emitter activity. This is just an on and off toggle. The interesting thing is that you can definitely animate this toggle, but we also have an interesting tool that will let us turn on and off this emitter in bursts, which is the duration of the burst parameter and the time between bursts. So notice how time between bursts is equal to 0 seconds. This means that it's off. So if we increase this value, for example, 0.5 seconds, you'll notice the flames come on and off exactly at a rate of half a second. Now, if we decrease the duration of the burst, for example, to 0.05, these bursts will be extremely fast. So let's increase the duration of the burst to, say, 2 seconds. And also let's make the time between each burst a bit higher. Let's go with 3 seconds. So this could be useful to create muzzle flashes or micro explosions. So let's turn off the bursts for now. Let's go back to 0. And now we have the transforms. So notice that we moved the shape a moment ago. I moved the shape upward, but the emitter has its own transforms. Notice how we have a pivot on the base of the domain. So by default, the pivot of the emitter object is exactly on the world center. But we can change this. For example, we could move the emitter. And again, this is an additional offset from the actual shape. And we could also rotate the emitter. For example, if we want to create a rotating motion, we could definitely rotate the emitter as well. For now, I will bring back to 0 all the transform values. Okay, so now let's talk about a very important property within the emitter. And you can click on the emission tab. And here we have actually a group of properties which refer to the type of information which is being generated from our emitter. And first of all, we have the fuel emission. And what I'm going to do actually is going to turn off fuel. I'm also going to turn off smoke emission. And same for temperature. I'm going to turn it off for now. And of course, now we only have the emission object, but no flames, smoke, or even temperature. So let's go one by one. Let's turn on the fuel emission. Let's click on Add. And remember, we talked about how combustion works. In order to have a combustion going on, we need some temperature and fuel at least. So let's now turn the temperature emission. So I'll click on Add. Now that we have fuel and temperature, we can definitely control both of them with the rate parameter. For example, let's bring the temperature rate down to about 500. So we still have the flame, but it's not burning so hot now. And now let's decrease the fuel. And as we know, eventually the flame will come out. Of course, we can do the opposite. We can increase the fuel rate if we want a faster burning flame. And of course, we can increase the temperature rate. Now, before we add some smoke, I want to show you the emission gradient. So as I increase the emission gradient, you'll notice that the fire extends beyond the emission geometry. If we want the fire to be emitted tightly within the geometry, we can decrease the emission gradient to 0. So I will leave it like this for now. Now let's turn on the smoke emission. So just click on Add, and we can now increase the smoke rate as well. And actually, I will increase the emission gradient as well. So now we can see the smoke and the fire. Of course, right now the smoke is too dense. Let me bring the smoke back down. Something around 200. And also let me bring the temperature back down a bit. Okay, let's go with these values because I actually want to show you how the pressure works. And the pressure can have a great impact on how your flames or fire look. Notice how by default the pressure is set to 0. I will slowly increase the pressure and you'll notice how the fire starts to bulge outwards. And this can be very useful to create very fast moving fire, or even explosions. For example, if you want to create an explosion, you could rapidly increase the pressure rate and then bring it down. And this is one of the very nice things about Embergen. We can see all these changes in the parameters in real time. This will let you prototype your effects in a very fast way. Okay, so let's reduce the additional pressure to about 50. And here we have a couple of more parameters. The pressure normally is added a bit randomly. So notice how the random intensity is set to 75, which is quite high. I'll even bring it higher to about 100. And now we have a more natural feeling, more random as the parameter says. You can also increase the scale in the pressure randomness. And of course, you can change the seed in each one of these two. Okay, now let's continue. So under forces, you have the velocity transfer. And this parameter is not very obvious, but if you take a look at the emitter and you move it around, you'll notice how the emitter is pushing the smoke and the flames quite a bit. Now, if I reduce the velocity transfer to say 50, this effect won't be so evident. And I think by default, the velocity transfer is quite high. So usually if you have moving objects, for example, characters or vehicles, you can definitely bring the velocity transfer down quite a bit. So we can go to 0. Of course, this might not look very natural. In this case, we don't see any transfer at all. So I'll go back to 50, which for me seems more natural than 100. And I will return in a moment to talk about more of the simulation properties. Okay, so now we're going to explore the rest of the simulation parameters, which are quite a few. So remember we talked about the domain size, basically the resolution of our domain, and the time steps. But there's also many parameters within the simulation that will affect how your final simulation looks. First of all, let's take a look at the combustion properties. Notice here we also have a generated smoke percentage, which we can increase, of course. For example, you can increase the overall amount in your simulation. And this may seem a bit redundant at first because we also have a similar control within the emitter. But imagine that you have several emitters in your scene. You can bring the overall smoke density or amount with this centralized parameter. And same for the flame intensity. We can increase the flame intensity in the overall simulation, even if we have several emitters. Now, below the combustion parameters, we have the dissipation, which is also very important. And actually, I want to bring down the pressure on the emitter, probably to around 5%. Same for the random intensity. I'll bring it much lower. And let's go back to our simulation node. Okay, so we were talking about the dissipation. If we increase the temperature dissipation, for example, and I will do it as well with the flames dissipation. I will increase dissipation for both of them. We will eventually notice that the flames will be reduced considerably. Now, same for the smoke. If we increase the smoke dissipation, we will reduce the life of the smoke overall. As for the diffusion, usually the more diffusion we have, the blurrier the fields will be. For example, if we increase the temperature diffusion, you'll notice how the flame is much smoother now, almost like a candle flame. And we can do the same for the smoke. We can increase the smoke diffusion speed and we'll get a very blurry result. So this can be very useful to stylize your effects, but overall I like to bring this down to 0. Usually you want these very sharp details, especially with fire. Now the vorticity will let us add some detail in the motion of the flames. We can increase the vorticity and you'll start noticing, especially on the edges, how we get more breakup. And usually this is divided into low vorticity and high vorticity. So I'll decrease the low vorticity and now increase the large vorticity. And it's basically the scale of these details that are being generated. Of course, you can combine them. Now we're starting to get a very frantic motion, so I'll reduce these values a bit. And one other thing that you can do with this vorticity detail is mask the effect with temperature or with smoke. For example, if we increase the temperature mask, we will mainly have the vorticity injected where we have larger temperature values. Or, for example, we can bring the temperature to 0 and increase the smoke. And now we should notice a reduced amount of vorticity on the flames. Now, this is not extremely obvious because in the end we have both smoke and fire interacting, but it will give you a bit more of control when adding the vorticity to your simulation. Now we have the forces, which are extremely important in your simulation's look. First of all, we have the force tightness, which refers to the amount of control that external forces are having in the simulation. And for now, I'm going to skip this value because we won't be able to see this effect since we haven't added additional forces. We're only using the simulation forces to shape this simulation. But within this group, probably one of the most important forces acting on your simulation is the buoyancy. Buoyancy is how much lift the flames and smoke will have depending on the temperature. So the higher the temperature, the higher the buoyancy on both flames and smoke. But we can decrease the overall amount by reducing this buoyancy value. So notice how the flames are not rising nearly as much as before. We also have smoke weight and fuel weight, which are both influenced by gravity. For example, if I increase the gravity, you will notice how eventually the smoke and flames will tend to fall. Let's start with the smoke, for example. Let's increase the smoke weight and reduce the buoyancy to 0. We can also bring the emitter upward to see this effect. And now let's also increase the fuel weight. And of course, this is a very unnatural effect. But for example, if you want to do an effect like dry ice, you can definitely use buoyancy and gravity to achieve it. Let us turn off the fuel. Also, let's turn off the temperature. And let's increase the smoke rate to about 250. And back to the simulation, I believe we increased the dissipation of the smoke. So let's reduce that. Let's bring our emitter shape higher. And back to our simulation parameters, let's play with both the gravity and buoyancy. So let's bring back the gravity multiplier to 100 and reduce the smoke weight. I also want to turn off the vorticity for now. And now we're getting a very interesting effect. So this could be dried ice or even a very large body of water falling down. Okay, so let's go back to our forces. And here we also have the ability to create a solid ground, ceiling, or walls. For example, if we want the smoke to collide with the ground, we can turn on solid ground. And let's do the same with all 4 walls. And now the smoke will be contained within the domain and react with the domain's walls. Let's increase the smoke weight a bit. And this is looking very interesting. Okay, so now let's take a look at the wind, which is quite straightforward. The wind can blow in any of the 3 directions. Notice how by default it's blowing on the y-axis, but we don't see the effect because the wind speed is set to 0 by default. So let's slowly increase the wind. The wind usually has a very strong effect, so be careful with that. I'll reduce this to about 0.05. And now we'll see the smoke being pushed towards the back of the domain. So let's rotate the domain a bit. And now let's change the direction of the wind to -1. To make the smoke blow in the opposite direction. Now, one other thing that we can do is induce a bit of randomness, of chaos. So you can increase the wind chaos parameter. This will make the wind look more natural. I would always recommend using a bit of wind chaos. So let's move on to shredding. Shredding will be more visible with fire. So let's again bring back our buoyancy. First of all, let's bring our emitter shape downward again. Let's turn on fuel and temperature. And back to our simulation parameters, let's bring up the buoyancy and bring the smoke weight and fuel weight back to its defaults. And same for the temperature dissipation and smoke dissipation. And let's bring the buoyancy down a bit. Okay, so let's work with this. Now back to shredding. So what shredding does is, based on the temperature of the flames, it will decrease or increase the speed of the flames, and this will give a more natural look. Let's try increasing the shredding intensity. And notice now we have a faster and more chaotic motion, even some stretching of the flames, which is usually very natural. Now, of course, this is a very exaggerated value, but you can bring this down. And what I usually do is at least have 10 or 50% of shredding when I'm doing fire simulations. Now, if we scroll down, you will notice a visual parameter, which is mainly a gizmo. If you turn on this gizmo, you will be able to see the forces acting upon your domain. So this can be very handy when you're starting to detail your simulations. Okay, so now it's time to talk about another very important topic, which is shapes. Remember that an emitter needs a shape to be able to determine where exactly in space we want the emissions to occur. Of course, we already created a sphere, but now let's go through all the shape primitive parameters. So I'm going to do one from scratch again. I will remove this one and select the emitter node, click on the shape input, drag, and create a shape primitive. So we saw that the shape primitive by default will create a sphere that we can transform around. And the sphere is a very simple primitive. Basically, we have a radius, so how large we want the sphere to be overall. We can also transform the sphere, so move it around, and also rotate it. In this case, we won't see much, but it will definitely be useful if you have a box, for example. So let's do that now. Let's change the type to a box. And for the box, you'll notice we have 3 different sizes or 3 different size axes. So let's move this to the center again. Let's revert its rotations to 0. And now let's try changing the C size to about 0.5. So now we have a very thin box emitting the flames. And now let's check what other kind of objects we have. So we have a rounded box, a capsule, a torus, a cylinder, a round-edged cylinder, a tube, a cone, an ellipsoid, which is similar to the sphere but will also give us control of separate axis scale, and finally we have a hemisphere and a spiral. Now let's take a look at other shape types. So first of all, let's bring back our sphere. And within our emitter volume node, let's click again on the shape input, drag, and this time I will create a shape transform. Now, the shape transform may seem a bit redundant because we have a transform here on the actual shape primitive and also on the emitter. But you can think of the shape transform as a null object where you can parent several primitives. For example, let's connect this sphere to the shape transform. I'll disconnect it from the emitter. And now I'm going to create a couple of more shapes. First of all, I will create a box. I'll make it flatter. And I'll move it upward a bit. And now let's create a third shape. And this time I will create a cylinder. And let's reduce its height a bit. Now remember, we're connecting all these three shapes to the same transform. So this means I can click on the transform parameters and now I can rotate them all at once. Or even move them all together. So although the transform shape may seem a bit trivial at first, it could be quite useful when you want to create more complex emitter interacting with each other or other shapes. Now let's take a look at another type of shape, which is the shape burst. So first of all, let me remove the transform and the primitives. I'll click and drag from the shapes input, and now I will create a shape burst. So shape bursts are very good for creating explosions, for example, or very fast moving emitters. So first of all, let me reset the simulation by pressing R. And you'll notice a couple of spheres growing and then disappearing. And this is the actual burst. Now, if we take a look at the parameters, you'll notice that the emission type is set to single burst. I'll change this to repeated bursts. And now you'll notice how the spheres appear and reappear once the burst is over. So we can control the duration of the actual burst. For example, let's increase this to 1 second. And the separation between each burst. For example, let's increase the burst interval to 5. Actually, let's try with 3.5. Okay, so the burst control has a lot of parameters. Most of them will help you control the distribution and shape of the burst. For example, let's scroll down to the position and change the distribution shape to box random. And also let's increase the size of this box to 5 meters. Let's bring the emitter upward a bit. Now you'll notice how these spheres are created in a larger space. So let's make the box even higher. Let's try with 10. And now let's try changing the trigger order. So right now they're being generated from center out. Let's change this, for example, to Z axis upward. Let's reset the simulation. And now you notice that the spheres are being created from the bottom to the top. And of course, you can change the direction, for example, left to right or back to front by changing the axis. Finally, let's try changing the actual shape of the burst geometry. For example, to cylinders. Rings, or even spikes. So as you can see, you can create a big range of effects using the shape burst. Let's now take a look at two very important shape types. First of all, the noise shape, and then the blend shape. So let's remove the burst for now. And let's create a noise shape. So right now there's something very weird going on. Let's change a few parameters on the noise. First of all, I'm going to increase the scale. And now you'll start to notice that we have areas where the fire, fuel, and smoke will be generated, and some empty areas where we will have no emission. So the noise by itself is not very useful because it's being generated within the entire domain. But this is where the blend shape comes in. Let's disconnect the noise for now. And this time I will create a blend shape. Notice how the blend has two inputs, A and B. So on input A, I will create a shape primitive. In this case, our trusty sphere. I will bring it upward a bit. And on input B, I will connect my noise. Now, notice how we have the sphere, and there's definitely something happening. Notice how on the right side of the sphere, we have a gap. And this is being created by the noise. So if we take a look at the blend shape parameters, the blend type is set to smooth intersection, meaning it's going to intersect these two shapes together, the noise and the sphere. So let's go back to the shape noise and let's decrease the scale to about 10 or 15. And now the sphere looks more like a piece of cheese where we have some gaps and some solid parts. And this can be very useful because the noise will let us create more natural emitters. So let's try increasing the contrast between the gaps. So let's look for the bias property. And let's increase the bias in a positive direction. So let's increase this to about 0.7. And notice how the gaps are now larger. Now, one very interesting thing that we can do is we can animate this noise pattern. If we increase the animation speed, you will notice how this pattern will start to move. Let's try with 2. And this will avoid having the fire being emitted always on the same position. And this can be very useful, especially with very large emitters. And of course, we can change the detail within the noise pattern by increasing the octaves, the lacunarity, and even the gain to give a bit more contrast on the noise pattern. So play around with the noise and blend These two are very important tools that will help you create much more natural emission. Finally, let's talk about the shape modifier, which is new in Embergen 1.1. The shape modifier will let you change the shape of your base primitive. For example, let's connect a primitive and let's disconnect the blend shape for now. Let's bring the sphere upward. And actually, I'm going to change it to a tube. Now, on the shape modifier properties, you can increase the thickness. So say, for example, you want the thickness of the tube to be greater. You can definitely increase this value. But you can also change the type of modification. For example, to golf ball. Which will create some kind of mesh. Or we can create a shell. This is useful, for example, if you want to create a hollow shape. And finally, you can invert the shape volume, which I don't use very often, but maybe you'll find some interesting uses for it. So let's go back to our shape for now. Let's change the shape to a box. And under the shape modifier parameters, let's change the shape to rounding and increase again the thickness. Finally, the shape import and the shape particles we will learn in a future tutorial. Let's now take a look at how forces work in practice. So as usual, we're going to start from scratch. First of all, let's create a scene node. I will connect my shading, and to my shading, I will connect a directional light. Now on the scene's volume input, I'll create the simulation. And from the simulation emitters, I will create a volume emitter. Let's now create a shape. In this case, I will create a primitive. And I will make this a box. I will increase the box size to about 20 meters. By 4. And finally, I will increase the domain size. So let's make the voxel size 0.4. And the voxel count 128 voxels all around. So I will click and apply new resolution. And let's take a look at what we have. Okay, so for this particular exercise, I just want to visualize the smoke. So I'll go to the emitter and let's turn off fuel emission. Finally, I'm going to reduce the buoyancy so the smoke doesn't rise so fast. And I will make the shading of the smoke much denser. So first of all, let's take care of the buoyancy. We know that's under the simulation node, under forces. I'll bring the buoyancy down to about 5%. And we haven't talked about shading yet. We will later, but for now, I'll just select the shading node and increase the smoke density. Let's go with this. Okay, so currently our simulation is extremely boring. What I want to do is start shaping this simulation using the forces. Now, notice how we have a forces input on the emitter node, but we also have a forces input on the simulation node. So what's the difference? Let's take a look. First of all, I'm going to duplicate this emitter. So I will select both nodes, the shape primitive and the emitter volume. I will press Ctrl C to copy the nodes and then press Ctrl V to paste them. Now I will connect the sector emitter volume to the emitters on the simulation. So as you can see, you can connect as much emitters as you need into a simulation. Let's now offset these two primitives. And to keep our scene ordered, let's call one of them left and the other one right. So you can right-click on a node to rename it, or you can also click F2. Let's call this one shape left. I will select the other shape, press F2, and call this one shape right. We can do the same for the emitter. I'll press F2. We'll call this emitter left, and the other one emitter right. Perfect. Now let's click on the forces input of the right emitter, and let's create one of the most basic ones and one of the most useful as well, which is the force noise. Now notice how the emitter on the right has a much more turbulent motion, but the emitter on the left hasn't changed. Now, if we connect this force into the simulation node, notice how both of the emitters are being affected by this force. Now, normally the forces tend to feel stronger on the simulation. Of course, that's not a problem. We can always tweak the values of these forces. Now that we understand that we can apply our forces in different levels, let's continue our work with just one emitter, and I will stick to the simulation input. So I will keep the noise force here. For now, I will disconnect the right shape, and I will center the left one. I will change its position in X to 0. And probably at this point, the left and right names don't really make a difference. So I'll just change the name again to shape. And same for the emitter. I'll press F2 and change the name to emitter. Okay, so let's again select the noise force and let's go through its parameters. First of all, we have the force activity. This is an on-off toggle. The mode parameter determines what we are affecting with the force. It could be volumes, particles, or both. And you can select the option with this drop-down menu. For example, if we change to particles, you will notice that the volume is not being affected. Since we don't have particles, this is pretty much the same as not having the force active. So let's select volumes only. And now let's take a look at the scale. So scale refers to the size of the detail that's being generated with the noise. For example, if we increase the scale to 20, you will notice a lower frequency pattern on the noise details. Now, if you want to increase the influence of the noise force, you can increase the amplitude of the noise. For example, let's increase the amplitude to 20. Now, of course, that for this particular simulation, these values are extreme, but let's bring them down. For example, let's bring the amplitude down to about 1 or 1.5. And let's reduce the scale to about 10. And we can even bring the amplitude lower. You can also increase or reduce the animation speed. And we could also give more detail and contrast to the noise features using octaves, lacunarity, and gain. Something very useful in the noise parameters is this preview. in black and white that gives you a very good idea of how large the features are, how much contrast and how much detail you have in the noise pattern. So as you can see, just by adding a simple noise force, you can greatly increase the detailing in your simulation. Let's now take a look at the line force. The line force can be a very versatile force. It can be used to create, for example, directional wind or even tornadoes. So first of all, let's turn off our noise force. So you can click on this small icon on the top right of the node. And now let's click on the force input on the simulation node. And let's create a line force. One more thing I'm going to do is reduce the shape size to about 10 by 10 meters. And finally, I will reduce the buoyancy to 0. So in this case, all the motion of the smoke is being generated by the line force. So you'll notice that if you select the line force node, you will see a gizmo that indicates the position and the direction of this line force. This will come in very handy. Now, the line force has three main parameters. First of all, the push strength. This is what pushes the volume or particles in a directional way following this arrow. Let's gradually reduce the push strength. Let's go with 0.1 for now. Now, another very important parameter is the twist strength. For example, let's increase this strength, and you will start to notice that we start to get some kind of tornado. And actually, the gizmo changed to reflect the direction of this twist force. Let's try decreasing the twist strength even more. Notice how negative values will make the tornado twist on the opposite side. And finally, the repel strength will push the volume or particles away from this line. Now, one very important aspect of the line force is its position and orientation. For example, let's try moving this line towards the right, or even rotating it to make it diagonal, for example. Okay, so I'll press Ctrl C to undo. And let's go back to its parameters. You'll notice how most of these forces will have a chaos parameter, which is very important. I usually add at least a little bit of chaos to my forces. So notice how chaos intensity is set to 0. Let's slowly increase this value. We could increase this intensity by typing a numeric value. And same as with the noise, we have a chaos scale, which is the size of the patterns. Let's try increasing to 5. And I think the position of the line is not centered. Let's change the X value to 0. And now we're starting to get something very interesting. Let me try reducing the twist strength. And of course, you can combine your forces. So I'll turn on the noise again. And I will increase the amplitude of the noise. And this is one of the great things of Embergen. You can always tweak your simulations in real time. So let's reduce the amplitude again. And probably increase the scale a bit. Let's go back to our line force and try increasing the push strength again. And the twist. Okay, so as you can see, the line force can be very useful to create very natural looking effects. Let's now move on to the next force type. Let's now take a look at the point force. So I will delete the line force. I will also delete these shapes and emitter. And for now, I will turn off the noise force. And again, I will increase my buoyancy. So I will go to Simulation, Force, and change the buoyancy to 5%. Okay, so to create a point force, I will right-click on the node graph, go to the Force menu, and select Point. I will connect the point force to the forces input in the simulation. And notice how the point force is also very dependent on its position. First of all, what I want to do is increase the repel strength. So notice how the smoke is being pushed upward and towards the left. And as we move the point force around, the smoke is trying to avoid the center of this force. Now, right now, this value is very high. Let's reduce the repel strength to about 0.2 or even 0.05 to make a more natural motion. Now, as I mentioned before, most of these forces have the chaos parameter. By default, it's usually set to 0. Let's increase the chaos intensity gradually. And in this case, I will reduce the chaos scale to about 0.2. And I will go back to my repel strength. And this time I will make the value negative. So notice how negative values attract the volumes or particles towards the force's center. And this can be very useful. Now, one other important parameter is the falloff. So by default, the falloff is set to none. But we can change this to linear, quadratic, cubic, or custom. So the ones I usually use the most are linear and quadratic. So let's change this to linear. And notice how the effect of the force is now being limited by this radius. So as we increase the falloff radius, we will start influencing this volume again. I will increase the repel strength. And I will move the force towards the left. And what I'm going to do to better visualize the falloff is copy this emitter again. So let's move this shape towards the left. Copy and paste the emitter. Connect it to our simulation and move the second emitter towards the right. So notice how the emitter on the left is being affected much more than the one on the right. And this is where the falloff radius comes in. Let's try to increase the radius to also influence the emitter on the right. And now let's move the force towards the center a bit. We can also move it upward. And this way we will only influence the smoke that is rising higher. The falloff parameter can also be found on the line force. Let's turn this force off for now. Let's connect a line force. I will rotate the force. Move it upward. And now I will turn on falloff, make it linear. And notice how only the higher reaching smoke is being affected by the force. Let's increase the force a bit. And let's also increase the falloff radius. So as you can see, the fall-off parameters can come in very handy. Let's now take a look at the Vorticle Force, which is also very interesting. So I will delete all these nodes. I will only keep one emitter. I will center the shape to the domain. And now I will create a Vorticle Force. I will also increase the size of the shape. For now, let's go with 30 meters. And let's go back to our Vorticle Force. So the Vorticle Force is similar to the noise force, but the main difference is, first of all, it creates some kind of twist or rotating force. And secondly, this force is very localized. And of course, it's quite random, but we can control how many of these vertical emitters we want to generate. So let's start with that. Let's find the verticals count and reduce this to about 5. So notice when we have verticals nearby, we get a bit of a swirly motion in the smoke. Let's now try increasing the force. So click on the Force tab, and here you will have the twist velocity and push velocity. So notice how push velocity is set to 0, and this is why we're only getting these twists on the volume. But that's fine for now. Let's increase the max twist velocity to about 20. Let's also increase the min twist velocity to about 10. So now we will have a much larger effect overall. Now I will reduce these values again. I will click on this arrow to reset the values. And let's start increasing the push velocity. So I will slowly increase the max push velocity. And of course, this will make a much more turbulent motion. But what I like about the verticals is that they're quite random in where they are being positioned. So this gives a very natural and organic looking effect. Now for the shape and positioning of these verticals, of course that we can control them. So first of all, we have the shape size. We can definitely increase the shape of these verticals. So we will get larger twists. I will reset that for now. And if I go to the Live tab, we can change how much these verticals live and how much they move around. With the min and max lifetime, we can determine how much time these verticals live. Finally, under the Position tab, we can affect how much these verticals move around with the advection intensity. For example, if we reduce the advection intensity to 0, these verticals will pretty much stay in place. Finally, let's take a look at the toroidal force. First of all, I will disconnect or turn off the verticals. I will click on the forces input in the simulation and select Force Toroidal. At a first glance, the toroidal force seems very similar to the line force, but it has a slight and very important difference. You will notice that if we increase the push strength, rather than only pushing the volume in a linear direction, we get a curve. And this can be very useful to create large vortices or even curve your volumes. So let's try increasing the shape. I will go with 50 meters. Now I will select my toroidal force and move it towards the right. So notice how our volume is curving in a very interesting way. Let's try increasing the radius size of this force. I will also turn off the buoyancy of the simulation. That way we're only seeing the resulting force applied on the volume. Now, if we take a look at our simulation from the side, you will notice a very interesting shape. This kind of motion is very difficult to generate without this force. Let's now try increasing the chaos to make this more interesting. I will bring the chaos intensity to about 2000. And also increase the chaos scale to about 2.5. And now you can move around your force. And as you can see, this toroidal force can be used to generate effects like solar flares, magnetic fields, or even magical effects like force fields and shields. Let's now talk about colliders. Colliders are a straightforward and yet very important tool. So as usual, let's start by creating our simulation from scratch. I will right-click on the node graph and create a scene node. I will connect my shading node, and to the shading node, I will connect this time an ambient light. To the volume input, I will connect a simulation node, and to the simulation node, I will connect an emitter, in this case a volume emitter, and I will also need a shape. I will change the shape type to box. Now I will move the box upward. And I will increase its Y size. This should be fine. Now, for now, I will turn off the flames. So go to the emitter volume and turn off fuel emission. Let's increase the smoke rate to 100. And under the simulation tab, I'm going to change a couple of parameters. First of all, under force, buoyancy, I will change the buoyancy to 0. And I will gradually increase the smoke weight. What I want to see is the smoke falling. I will also reduce the dissipation. So I will bring down the smoke dissipation to about 5%. Now I will go back to forces and probably reduce the smoke weight. Let's go with 25. I want the smoke to fall, but not that fast. Now I'll probably add a directional light just to have a bit more contrast on the shadows. Now we can start creating our colliders. So here under the simulation node, you will notice we have a collider input. So click on that input, drag and create a collider node. Now, same as with the emitter node, we need a shape to act as a collider geometry. So let's create a box. First of all, create a primitive shape. Then change its type to box. And if you drag this box around, you will notice how the smoke is colliding with the box and moving around it. Of course, we can turn off the visibility of the collider. But for this exercise, I will keep it on. I will reduce the size of the emitter a bit. I will change the X size to 2 meters. And the Y size to about 8. Okay, so let's try now moving the collider a bit upward and even rotating it. I will even flatten the collider a bit and probably make it larger in X. Something like this. So notice how the smoke is sliding down the box, which is very natural. Let's try creating another collider. So click on the shapes input and click on shape primitive again. I will change the type to box and move the box upward. So of course, now we're getting interaction with both primitives. Now, one very important parameter that I want to show you is the velocity transfer property. Notice how by default this property is set to 100. Now, what this property does is when you're moving your collision objects, the objects will push or advect the volumes around. Of course, the faster your collision object is moving, the more effect it will have on the velocities of your simulation. If we were to reduce this parameter, for example, to 0, this collision object would have very little effect on the velocities of the simulation. Of course, the smoke is still being displaced by the collision object, but we're not transferring the velocity from it. Just be mindful of this parameter because the default value can be quite extreme. We will now take a look at how to generate animation within Embergen. I have a very simple scene here, and what I'm going to do is use the emitter to create several types of animation. First of all, we need to know how to change the overall state of a parameter. And as an example, I'm going to select the shape primitive that is serving as an emitter for my simulation. If we take a look at the transforms, the rotation, for example, to the left we have a small toggle. This toggle has 3 states. The first time you click on the toggle, you will activate the timeline override, which will be represented with a diamond shape icon. You will also notice in the timeline the parameters are shown with the same values that are set on the parameters window. Now, the second time you click on this override, you will create a pin. Notice how the parameters are gone from the timeline, but now on the node, we have an input where we can connect other nodes to control these values. For now, let's try adding keyframes with the second override, which is a timeline override. So I will click twice to display the parameters in my timeline. And now to create a keyframe, you can shift click anywhere on the timeline. This will create a keyframe with the current value, but you can always change this value. For example, I can right click on the keyframe, change the frame, for example, to frame 10, and also change the value, for example, to 45 degrees. To have an animation, I would need at least 2 keyframes. So I will create a second keyframe. I'll press Shift and click on my timeline, then right click on my keyframe and change its value, for example, to -45. Now, if I reset my simulation and press play, you will notice how the torus is rotating. If you want to get rid of this animation, you can either select the keyframe and delete the keyframe, or click the override once again. Let's reset the simulation again and press play. What I'm going to do now is turn the fire on and off, creating a few simple keyframes. So I'll select my emitter, stop the simulation, go to frame 0, and under emission, I'm going to look for the fuel rate value and set it to 0. I will click on my override once to activate the timeline override, and on frame 20, I will shift click to create a keyframe, and then I will create a second keyframe around frame 40. So I'll press shift click, and another way we can change the value of a keyframe is navigate exactly to that frame number. So we can do this by jumping to the next keyframe. You can also press the right key. And now I will change the fuel rate to about 100. Notice how this keyframe changed its value which means it's now animated. So I will reset the simulation and press play. Notice how the flame is turning on, and what I'm going to do is turn the flame off after a few seconds. So around frame 240, I'll press shift click. I will now create another keyframe around 280. I'll press shift click. I will move forward to this new keyframe and change its value to 0 again. So let's reset the simulation and press play. And now we have the fire turning on and off. Let's do the same with the smoke. On frame 19, I will turn off the smoke, set it to 0, and click on the override once. So I'll create a keyframe, move to frame 39, and create another keyframe for the smoke. Set its value to 100. Again, step forward to the next keyframe. I can shift click to create a new keyframe for the smoke. And finally, I will move to frame 280 and change the smoke rate to 0. Reset the simulation and press play. So as you can see, animating in Embergen is very simple. Let's now take a look at how we can fine-tune and better control our animation. For that, I'm going to remove the keyframes that we created on the fuel rate and smoke rate parameters. So I will select the emitter and click on the override state of the fuel rate. I will get a warning asking us if we're sure that we want to do that, and this is because it will remove all the keyframes. In this case, that's what we want. So I will click in continue and click one more time in the override. I will do the same thing with the smoke. I'll click once, confirm on this warning, and click one last time on the override. And now what I'm going to do is create a few keyframes for the rotation. So I will go back to my primitive shape, click on the rotation override, and let's start by creating a keyframe anywhere on the timeline. So I will press shift and click, and then to precisely set the timing and the value of the keyframe, I will right click on it, and on this menu I will type rotation 0 degrees and frame 20. Now I will move to frame 100 and change the value of the Y rotation to about 120. And a new keyframe will be created. If this keyframe is not created automatically, make sure that this toggle is on, toggle timeline auto key. You can also press the A key on your keyboard to toggle this on and off. Okay, so we learned how to numerically change the values of these keyframes, but we can also interactively change the timing and the value of these keyframes. First of all, what you can do is click on this icon named Toggle Curve Editor, and this will show you a curve representing the current animation. Notice how we can turn on and off certain channels to make this view more or less cluttered. In this case, I will turn off the X and Z parameters because I'm only interested in the Y rotation. So I will go ahead and create one more keyframe by pressing Shift and click, and then one more around frame 320. Now, within the timeline, you can click and drag to create a selection of keyframes. Now, let's say we want to move these keyframes in time without changing its values. So I can press Shift, click and drag to move them horizontally. If I only want to change the values, on the other hand, I can select the keyframe that I want to change and then press Shift, Control, click and drag. This way I'm changing the value, but not the time. So let's take a look at what we currently have. I'll press play. And now we have the torus rotating in one direction and then rotating in another direction. Finally, what we can do is change the interpolation of these keyframes. For example, if we click and drag to select several keyframes, then right-click on any one of them, you will have access to the interpolation mode menu. Let's try changing them to linear, for example. And now if you press play, you'll notice that we have now a linear motion that feels much more mechanic. Let's reset the simulation and change the interpolation now to constant. If we now press play on the animation, you'll notice that the torus goes from one angle to the other without any kind of interpolation, almost like an on and off switch. Let's revert the interpolation mode to Bezier, which is the default. And now let's explore what we can do with these Bezier handles. So you can click and drag the handles to reshape the curve, or you can right-click on the keyframe, go to handle type, and change these handle types to free, clamped, or vectored. For example, I will click on free, and now I have an asymmetrical handle that can be shaped into a very sharp angle. All these tools in combination will give you a very precise way of fine-tuning your animations. At this point, we've gone through a lot of the main Embergen tools, but still we have a lot of work to do. But at this point, instead of just creating nodes and showing you how they work, I would like to start working on our final project, which is this very nice battlefield scene. So notice we have some fire, we have some background smoke, and we even have some wispy smoke on the barrel of the gun. All this is being integrated into a photograph. And although it's not an animation or video frames, the methodology used on a still image is exactly the same as with an image sequence. For this particular project, we'll start by creating a reference ground plane. Then we will create our camera and match it to the background plate. We will generate our collision objects, and of course, we will create our several simulations. After that, we will add some lighting to our scene and learn how to tweak our shaders. Finally, we will learn to render all our effects elements and create our final composite. So as you can see, we have a very fun project ahead. So let's dive into Embergen and let's get to work. We are now ready to start working in our final project. Now, of course, you have the option to start using this template file as a starting point. But as I've mentioned before, my interest would be for you to get very comfortable using all the tools from scratch and learning their most important parameters and attributes for you to really be able to control your simulations. That being said, let's again remove all the nodes from the graph. So I will select them and press delete. And as usual, I will start by creating our scene node. As usual, I will create my shading node and also my simulation node. Finally, Embergen will prompt me to connect a light to the shading node. So let's do that. But this time I'm going to go with an ambient light. Since we're going to work a long time on this file, it would be a very good idea to save it now. So I will go to File, Save As, and in my project folder, I will save this file as Battlefield Barrel version 1. Now, something that we haven't used so far, and to be honest, something that I use pretty much every single time, is a ground plane. So you'll notice on your scene node, we have a ground input. I will click and drag on this input to create a ground plane. And this is an infinite plane that can be very useful as a reference. First of all, to look at shadow interactions, but it's also a very good reference to look at our perspective and also to understand the space we're moving in. Now, although the ground doesn't really have too much options, you can definitely change the way it's rendered. For example, by default, we have a grid, but we can change this to checkerboard, noise, or a uniform color. For now, I'll go back to grid, and you can also change the height of the ground with the ground distance parameter. In this case, I will revert it to 0. You can also change the material scale. For example, if we want 1 meter tiles, we can change this here. And we can also select how far the light and shadows will be cast. For example, if we reduce this radius, we won't be able to see too far away. Again, I will revert this value. And for now, that's pretty much all you need to know about the ground plane. Let's now create our camera for our scene. Now, creating a camera is not as intuitive as it may seem. Of course, I can right-click on the node graph and type camera. But if you take a look at the scene node, there's not a camera input for us to connect this camera. But if you click and drag on the scene output, you will notice that you can only create a render node. So let's do that now. And here you will notice that we have the camera input. So let's connect the camera here. And just remember, the next time you want to create your camera, you first need to create a render node to connect it to it. Notice how we can see the camera icon on the viewport. If we would like to see through the camera, we can go on this top menu and look for the default camera and just change it to camera 1. Now, one important thing that I would like to do before we continue is change the name of the camera to make it clear that we want to render through it. So I'll call this render camera. Now, one very cool thing is that we can still orbit, zoom in and out, or pan the camera around. So as long as we're looking through it, we're actually moving this camera parameters. So for now, let me zoom out a bit. And I will change the view to default. And let's try to see the camera on our scene. And here it is. So now let's take a look at the camera parameters. So first of all, we have the ability to lock the camera. Now try to pan. I won't be able to move it around. And this could be very useful once you've set your camera. So let's unlock it for now. Now, of course, we can change the position and the rotation of the camera. But to be honest, I prefer to move the camera around through the perspective view. So I'll revert these values. I can also change the near and far clipping plane for render. And if I scroll down, I will see the display parameters. So I can change the projection type from perspective to orthographic. In this case, I will revert it back. And I can also change the field of view to make it resemble more of a macro or a zoom lens. Again, I will revert this value. And one very important thing that we're going to use on this particular project is this option called Use Backplate. So this will allow us to add an image projected in the background. So let's click on Use Backplate option. And here you will have the ability to import your background file. So I will click on this folder and look for the image in my project folders. And of course, this background image will be provided with the project files of this tutorial. So let's open the file. Notice how in case you had an image sequence, you could definitely define the frame rate of the image sequence and at what frame does the sequence start. By default, the animated backplate is off. But of course, you would need to turn this on in case you had that sequence. Finally, what we need to do is define the display and render resolution of the camera. Now, what I would suggest to do is to use the exact resolution of the image. Now, the camera node has a very handy tool called Set Display Resolution from Backplate. And this is exactly what we're going to do. I will click on this button, and now the camera render and display resolution will match the image background. Let's now create the collision object for the barrel that will be on fire. So let's select our simulation node, click on the collisions input, and create a collider. Now on the collider input, let's click and drag to create a shape primitive. For this shape, I will select a tube, and I will change the tube size to 5 meters radius and 14.6 meters in height. And if you're wondering where I got these values, I did some previous testing and I found that this size worked very well with the flames details. One thing that I've noticed with Embergen is that you usually want to create your objects larger than they would be in real life. Now let's go to our viewport and press T. Remember, T will center the selected object on the view. And I'm going to zoom in a bit, probably pan and orbit the camera. And actually I will change the radius to 5.2. Now let's use this tube as a reference to position the camera as closely as we can to the background plate. It doesn't have to be exact. Remember, you can always go to the camera parameters and transform it numerically. Once you've matched the barrel as close as possible, make sure to save the file, pressing Ctrl S. Now, if you're having a hard time matching your camera to the background plate, you can always open the provided file, copy the camera, and paste it into your scene. Now that we have our collision object and camera in place, we can start creating our fire effect. On this particular video, I will go through my thought process when creating the fire for this particular shot. But by now, you should be comfortable tweaking the fire parameters and creating your own style of effects. That being said, let's continue with our exercise. First of all, I'm going to start organizing my nodes. So one thing you can do in Embergen is select one or several nodes and create a backdrop or a comment for them. You can right-click on the node graph and select Create Comment from the menu. Now in this particular case, I will call this Collider and press Enter. And whenever necessary, you can click on the backdrop and move it around to organize the nodes. Let's now create the emitter for our fire. Select your simulation node, click on the emitter's input, and drag to select emitter volume. Then in the emitter volume input, select Shapes and create a shape primitive. In this case, we'll use the default sphere. What I'm going to do for now is move the emitter upwards about halfway through the cylinder. So we can definitely change to the default view if we want to tumble around the scene. In this case, I will zoom in and press T to center around the emitter. Consider that you can select the collider and turn it off to be able to see your emitter. Okay, so let's make the emitter a bit larger. I will click on the primitive shape, click and drag the radius to interactively increase the size of the emitter. Now remember, since we have a collision object active, the emitter will eventually go through the collision object, so make sure to always keep it smaller than the cylinder. Okay, so with our emitter in place, I will select my simulation node and decrease the buoyancy to about 10%. Currently, I don't want the flames to reach that high. I can even probably go lower. Let's go with 5% for now. And as we learned in previous chapters, it's a good idea to add a bit of noise to break up the emission and also your simulation. Let's start by adding noise to the emitter. So click in Forces, drag and select a noise force. And I will increase the amplitude of the noise to about 10. let's go with this for now. And I will do the same for the simulation. I will create a noise force. And in this case, I will increase the scale to about 15 and the amplitude to about 10. Now, this seems a bit extreme, so we can click and drag the amplitude to decrease it gradually. And for now, I think I'll go with 4 and probably increase the buoyancy a bit. So I'll go back to my simulation and try with 10% buoyancy, or even a bit higher. Let's try with 15. And don't worry about the clipping of the flames and smoke. We can always increase the bounding box once we're happy with the main simulation. One thing that I want to check is in the simulation parameters, I'm going to try to increase the vorticity and shredding. Remember, usually these two parameters work well with fire. Let's start with vorticity first. I'll increase the intensity to about 20. This may be a bit too much. Let's try with 15. And let's go with this for now. Let's now try adding some shredding. So I'll click on the shredding tab and increase the shredding intensity. And I think this is looking quite nice. So one more thing that I want to do is take care of the smoke. Currently the smoke is quite faint, so I would like to add a bit more smoke. I will select my emitter, click on the emission tab, and look for the smoke emission. So I will increase the smoke rate. I will click and drag this parameter to increase the smoke gradually. And for now, I will go with 40%. Remember, you can always come back and almost interactively tweak your parameters to adjust the simulation to your liking. Let's again display our collider. Go back to our camera view and check that the fire is working with the scene context. And I think this is good for now. Let's again save the file. Make sure you increase your version, and we'll be back in a moment. Now that we have the fire in a good shape, I want to talk about an important node called the volume processing node. You can either connect the volume processing node to the output of your simulation or to the input of the scene. In any case, make sure that this output is connected to the input of the scene node. And first of all, let me tidy up this workspace. I will move the collider downward, these nodes upward, and I will create another backdrop. I can select a couple of nodes, then right-click and create a comment. I will call this one emitters. And I will create one more comment for my forces. Okay, so now with our volume processing in place, let's first talk about these slicing mask tools. And for this, I will change my view to the default view and probably zoom out a bit. And one more thing I'm going to do is turn off the collider for now, just for us to better see the bounding box. Now, if we take a look at the slicing mask properties, we have an offset and a width for all three axes in the positive and the negative direction. Let me first work with a positive z-axis, which is called roof, and I will increase the offset to about 50%. Notice how we are clipping pretty much half of the bounds, which in most cases won't be very useful. However, the width parameters will create a soft gradient or transition between the current voxel values and 0. This will make a very soft transition towards the bounce edges, and this can be very useful. Let's try to do the same with the negative Z, or in this case, the ground width. For now, let's keep it at 20%. And of course, we can do the same for X and Y. So what I usually try to do is keep at least 10 or 15% in each axis. That way we don't have a hard cutoff on the edges of our domain. So let's do that. I will change the wall width to 15%, both in negative and in positive. Same for Y. And for the C positive, I'll keep 30%. Now let's talk about the volume post-process. By default, it's set to none, but you can definitely change this to motion blur. And this is very good for fast-moving fire, for example. So in this case, the motion blur intensity is set to 100%, but we could probably decrease this to about 10 or 20%, depending on the look you're after. One other thing that you can do is sharpen the volumes. So let's click on Sharpen Post-Process. Let's zoom into the fire. And now let's sharpen both temperature and flames. So notice how we have a more contrasty edge, mainly on the flames. Of course, we could do the same with the smoke, but I want to show you what would happen if we set a negative value. So notice how now the smoke feels a bit more blurry or diffused, which I think I like. Finally, you can change to dilate mode, which is almost the opposite as sharpen. So if you increase the dilate for the smoke, for example, you will get a more diffused look. But if you reduce this value to negative values, you will have the sharpening result. So in my particular case, what I'm going to do is select the sharpen mode and just dilate the smoke a bit by using a value of -50. And I think this is working nicely. Let's now take a look at the lighting tools. If you remember, we created an ambient light for this particular scene, and we have also created directional lights in previous exercises because Embergen requires at least one light for a simulation to be done. However, in this chapter, we will look at the lighting tools more closely. So first of all, if you go to the scene node, you will notice that we have a skybox, which I believe we haven't used so far. Let's click and drag on the skybox input and create a skybox node. Now, you will notice that nothing new has happened. Usually, we need to connect a directional light to the skybox. So let's do that now. I will click on the sun input, drag, and click on light directional. And now you will notice that not only we have a sky dome, but also we have this directional light that represents the sun. Now, the position of this light doesn't really have an impact on the lighting in the scene. In this case, only its orientation will be important. And for now, what I'm going to do is remove this ambient light and connect my directional light to my shading mode. Now we can clearly see that the orientation of this directional light will determine the direction of the sun in our sky system. Okay, so let's take a look at the light's parameters. So of course, the more important one would be the light intensity. We can make it brighter or dimmer. For now, let's go with a default of 1. One other very important is the light color. For example, we could give this light a blue tint or an orange tint to resemble, for example, the sunlight. Just keep in mind that a little bit of color can have a huge impact on your scene. So if you intend to use colored lights, make sure that they're extremely desaturated. For now, I will go with this. And then we have the inherit sun color. which is linked to this skybox. Notice how if we turn the skybox off, this parameter won't have an effect on the light. Now, what I would suggest is if you're doing exterior lighting, make sure to have a skybox because this will give a more natural lighting. And since we're inheriting the color from the skybox in this particular case, let's bring back the light color to white. The azimuth and elevation will determine the direction of the sun. So in this case, changing the azimuth angle would be the same as rotating your icon in the Z-axis. And changing the elevation angle would be the same as rotating it in X. Now, aside of the directional light, we also have a couple of more light types. Let me turn off the skybox and the directional light as well. So we explored the ambient light already. This one can be useful to create ambient occlusion or a flat colored environment. For example, I could change this color to a bluish tint and simulate a night shot. Other than that, you will be changing the ambient intensity. Finally, we can create spotlights within Embergen. And these lights are very good to resemble artificial lighting. For example, light posts or headlights on a car. Let's move the spotlight upward. And let's increase its intensity. Here we could change the cone angle and the penumbra angle, which will determine how soft is the transition between the hotspot and the shadow. And of course, we can create as many spotlights as we need. For this particular shot, I will keep my skybox and directional light. So I will delete this spotlight. Same for the ambient light. I will turn on my directional light and my skybox again. Now let's take a look through the camera. And let's also turn on our collision objects. These will give us a very good idea of where the shadows are being cast and where we're getting our highlights. Let's try to determine the key light direction on this particular shot. And for that, we can take a look at these specular highlights of this barrel on screen right. So notice how the light is coming from the right and above. Now this particular day, the sky was overcast. So notice how we have very diffuse shadowing. Especially you can notice on the ground. But still we have a relatively warm lighting overall. So let's have the light inherit most of the sun color. I will select my directional light and increase the inherit sun color to about 75%. Now I will rotate my directional light so I have it pointing from right to left and from front to back. Something like this will do. So now make sure to save your file and we'll continue in a moment. Now that we've gone through Embergen's lighting tools, let's talk about shading. Shading can be a very important part of the final look of your effects. Of course, we did create a shading node for this project, but now let's go through its main parameters. Before that, I'm going to change to the default view. I'm going to zoom into the fire and turn off my collision object. One more thing I want to do is increase the bounce a bit. So I will select the simulation node and add 64 voxels to each axis. And I will click on Apply New Resolution. Now, of course, we will have a slower simulation, but right now I will focus on the shading, so that's fine. Make sure to select the shading node. Let's first talk about the shadowing sharpness. And actually, I will turn on our collision objects just to show you this parameter. So if I reduce the shadowing sharpness, you will notice how we will get more diffused shadows on the shape objects. This can be important if you're going to cast shadows on matte objects for your final composite. For now, let's increase the sharpness a bit. Let's go with 50% and continue with the shadow density and intensity. So notice how if I decrease the shadow density in the ground plane, the shadow will seem more transparent. And actually for this particular exercise, I want to go with a value lower than the default, which I feel is quite high. So notice how 100% will yield an almost black shadow. So for this particular scene, let's go with 50%. Let's now talk about the scattering, which is the effect of light going through your volume and making it brighter. So if we increase the direct light contribution, of course that our smoke will look much brighter. For this particular scene, especially since it's an overcast sky, I will reduce the direct light contribution to about 10%. We can also increase the flame's contribution to the scattering or decrease it. Again, in this particular case, I don't want much of the light scattering, so I'll reduce it to 50%. Let's now focus on the flames. Probably the most defining aspect of the flame will be its color. And if we take a look at the flame's coloring parameter, it will be set to black body by default, which is a more physically accurate model for coloring flames. With this coloring model, low temperature values will show red, and as the temperature increases, that color will go through yellow, white, and blue tints. For example, let's try remapping the temperature values. I will decrease the maximum temperature, and you'll notice that now the colors are closer to white. On the contrary, if we increase the max value, we will get more ranges of red and orange colors. For now, let me revert these values, and I will now increase the shaping by flames value, which you can think of as the intensity of the flames. Now, although the black body is the more accurate way to represent colors in the fire, you can also change this value to a color ramp, which could be very useful to generate, for example, abstract effects. Let's try changing the color to a blue tint, for example, and I will press play again. Or we could change the tint, for example, to a green. And with this kind of ramps, you can have a lot of artistic control. Finally, the option where you will have the most amount of control is with the exposed color gradient. Now, with the exposed color gradient, you will notice that we will create an input called fire color on the shading node. And here I could connect a color gradient node. This node will allow me to control the colors in a very accurate way. Let's try adding an orange color to the fire. So I can double click on this tiny flag here and select an orange tint from the color picker. You can also click and drag these flags to change the gradients ranges. And you can also click within the ramp to add more of these color flags. So let's try adding a yellow tint this time. probably adding more contrast on the ramp. And finally, I will add a white color. Let's try to reduce the contrast on a ramp and get more of these yellow values. And one very interesting thing that you can do, you can also add some black colors. For example, I will click here on the ramp to create another flag and make this one black. This will make the hotter temperatures transparent and will give a very nice contrasty look to your flames. So let's try remapping the values. I will select my shading node and go back to my coloring remap parameters. I will slowly increase the maximum range until we see more of these orange and yellow colors. And now in my gradient color, I will create a bit more of contrast between these colors. I will take a time to tweak this shader and come back in a moment. Okay, so for now I'm going to go with this. I may tweak the fire before we render, but so far I'm happy with the result. Now on the shading aspect, I did increase the shaping by flames to 1000. And I reverted the coloring remap range to its defaults. For now, I will save the file and we will focus now on the smoke. So click on the smoke tab. Here we will have similar parameters than those we had with the flames. But particularly with the smoke, I would say that the most important parameter is the smoke density scale. For example, let's try doing a very dense smoke by increasing this parameter. And also for demonstration purposes only, I will increase the smoke emission overall. So I will select my emitter and change the smoke rate to 100. So for now, let's go with this. Let's go back to our shading node. And notice how the smoke also has a color parameter. By default, it's set to single color, but you can also change this to a color ramp or to an exposed color gradient, as we did with a fire. For now, I would just select color ramp. And now I can select between two colors, minimum color and maximum color. And these are mapped to the density of the smoke. For example, the denser parts will have a darker gray. In this case, let's make it black. And the less dense smoke will be lighter. In this case, let's make it white. Same as with the smoke, we can remap these ranges, but here instead of temperature, we're talking about the density of the smoke. For example, let's reduce the max range to have a bit more of that black smoke coming through. And of course, this parameter can also help you create more fantastic or stylized effects. For example, let's change the max color to something like blue. And the min color to green. Okay, so in this particular case, since I just want a very faint smoke, I will change back to single color. I will reset my remap values. And again, I will reduce the smoke emission to about 30%. And let's go back to our shading and reduce our density scale to about 50%. So in this particular case, I might go with a darker color. Always make sure to see your effects with a background plate. So I will change to the render camera and confirm that this is what I want. In this case, I think I will go with a denser smoke. So I will select my shading node and increase the smoke density scale to about 150. Now that we're happy with our fire, let's tidy up our workspace, save our file, and move on to the creation of the smoke. Since we already have our camera, our backdrop, and all our lighting, we can save the file with another name and create a new emitter. So in this case, go to File, Save As, and change the name of your file to Battlefield Smoke version 1 or something alike. Now the smoke column will be seen on the background, so we might not use a camera in this particular case. For now, I will select Default, and I will also turn off the collision objects since we won't be using them. I will also select the emitter and delete it altogether. I will probably do the same as well with the collider. Okay, so now let's create a new emitter. In this case, a volume emitter will do. And let's create a shape, in this case a primitive, and let's keep the type as sphere. For this particular effect, I want a larger container. So in order to be able to work in real time, I will reduce the voxel count and increase the voxel size. So select the simulation node, increase the voxel size to about 0.2, and click on Apply New Resolution. Now I will reduce the voxel count to 128 by 128 by 256 voxels. This will do for now. I will reset the simulation and select the emitter. Now for this particular effect, I don't need fuel or fire. So let's turn off the fuel emission and let's increase the smoke rate to about 250 and press play. I will delete the forces for now and change the smoke color. Let's go with this for now. Okay, so for the smoke column, I want a nice billowy smoke, which will slowly rise and have a slight wind from left to right. So first of all, let's take care of the buoyancy, which will greatly determine the look of the smoke column. So select your simulation node, click on the Force tab, and reduce the buoyancy to around 5%. Now go to the emitter node, increase the smoke rate to about 500 or 1000. Now to create the billowy look, I will add some pressure. Let's try with 25% for now. And I will also increase the pressure random scale to about 0.25. Now, notice how the smoke is dissipating quite fast. So let's go to the simulation node, find the dissipation tab, and reduce the smoke dissipation value. Let's go with 25% for now. And now we'll have a taller column. Okay, so one thing that I want to do on this particular effect is add a bit of breakup, and for that I'm going to add a few forces. First of all, I will create a Vorticle Force and make it very subtle. So I will scroll down to the min twist and max twist velocity and reduce this to about 0.1 and 0.25. I also want to reduce the number of vorticles. to around 20 and probably increase the scale a bit. So I will change the maximum radius to about 25. And this will add a bit of a breakup to the smoke column. Now let's add a bit of wind. So click on Forces again and select Align Force. Now for the line force, I'm going to rotate it so it's facing towards the right. I'm going to move it upward. And also I will make sure that it's pointing a bit downward. Something like this. Let's reduce the wind force considerably. So I will reduce the push strength to about 0.02. Finally, I will turn fall off on and make it linear. Since I want a very smooth fall off, I will increase the fall off radius to about 20 or 25 meters. Okay, so at this point I think I will increase the domain size, especially on X, since we have the wind blowing from left to right. So select the simulation node, go to Domain, and change the X voxel count to about 256. Click on Apply Resolution. And of course, right now the smoke column will be centered on our domain. What I'll do is select the smoke primitive and translate it towards the left. Okay, so at this point I might want the smoke to dissipate a bit faster. So select the simulation node, go to Dissipation, and increase the smoke dissipation value. I will also select the line force and increase the push strength to about 0.3. I will also increase the fall-off radius. Okay, so finally what I'm going to do is create a bit of a fall-off, especially on the top and right edges. So select the volume processing, scroll down to the slicing mask, and change the C positive roof width to about 40% and the X negative to about 30%. Finally, one more thing I want to do is add a noise force to the emitter, just to break up the bass a bit. So click on Noise, and you can increase the scale to about 15, and the amplitude as well. So at this point, what I would recommend is for you to tweak the smoke to achieve a nice look. You can also play with the shaders and the simulation parameters. So I will make some final tweaks to my smoke column and come back in a moment. Okay, so this is my smoke column with the final tweaks. A few things I did was on the shader level, I did change the coloring to color ramp. So I made the min color light gray and the max color a darker shade of gray. I also noticed that in the volume processing, we left the sharpening on a negative value, which made the smoke a bit diffuse for my taste, so I increased the sharpen smoke to 100%. One other thing I did is under the emitter volume, I increased the pressure random intensity and decreased the scale to 0.1. So as usual, you can continue to tweak the smoke column on your end, but in any case, I will save this file and will include it with the rest of the tutorial files for you. Now that we have created our fire and our large-scale smoke column, let's create a deceivingly simple effect, a wispy smoke. Although creating a wispy smoke simulation is not really complex, it does heavily rely on shading and post-processing. One other thing that sets wispy smoke apart is the scale. Usually wispy smoke tends to be small, but as I mentioned before, Embergen is a bit deceiving with the scaling. Sometimes you need to create larger emitters to convey the sense of a smaller scale, which is not very intuitive, but with practice, you can definitely master. So let's start as usual by creating our scene. I will right-click on the node graph and create a scene node. In the volume input, I will connect a volume processing node, which I will use every time moving forward. Now, on the volume input, I'm going to attach a simulation node. And under the emitters input, I'm going to create a volume emitter. And as usual, I'm going to create a shape and make it a primitive shape. Remember, we always need a shading node. So again, in the scene inputs, I will connect a shading. And to the shading, I will connect a directional light. Okay, so we're now set to start creating our effect. Let's first of all select our primitive shape and change the shape to a cylinder. I will create a relatively long cylinder, so I will change the height to 10 meters. And I will move it upward to prevent the clamping, around 11 meters high. Now remember, I'm doing a much larger scale object, but I will try to depict smaller sized detail in the simulation. So let's increase the bounds. I will select my simulation node, change the voxel count to about 150 by 150 by 400. I will also change the voxel size to 0.4 and click on Apply New Resolution. I will select my shape primitive and press T to center on the emitter. I will reset the simulation and press play. One thing in this particular case, we won't need fire emission. So I will select the volume emitter, scroll down to the emission tab, and turn off fuel emission. On the other hand, I want to increase the smoke. So let's change the smoke rate to about 100. We can even go higher than this. Let's go with 150. I think this is a good starting point. So let's go to the simulation, forces, and reduce the buoyancy. I will go with 35% for now. And one very important thing that I want to do with this emitter is break it up a bit. Because as you will notice, we can clearly see the cylinder shape. And this is something I want to avoid. So under the volume emitter, and in the shapes input, I will click and drag to connect a blend shape. So remember, the blend shape requires two inputs. First of all, I will disconnect the shape primitive and connect it to input A of the blend shape. Now for the shape B, I will create a noise. We've done this before. So remember, the noise shape breaks up our emitter. That way we have some negative space in some areas and other areas emitting the smoke. So I will increase the scale of this noise pattern. I will also add a bit of contrast, increasing the bias. And finally, I want this pattern to move, so I will increase the animation speed. Something like this will do for now. Now, I still feel that the smoke is rising a bit fast, so I will go back to my simulation and decrease the buoyancy to about 20%. Let's go with this. Now, one thing that I usually do, remember we can add some forces to the emission. So I will select the volume emitter, and under the forces input, I will connect a noise force. Now, I may want larger scale detail, so I will increase the scale to about 20 units. And I might need a bit more force, so I will increase the amplitude to about 8. And remember, all these you can tweak to your own liking. I'm just using these values as an example and as a starting point. Okay, so I think we have a good starting point. I may need a denser smoke, and mainly I don't want the smoke to dissipate this fast. So let's handle this first. I will go to my simulation, click on the dissipation tab, and reduce the smoke dissipation to about 30%. Now let's go to our volume emitter, and let's increase the smoke rate to about 200. Let's go with this for now. And finally, what I want to do is avoid the smoke clipping on the top. So I will go to my volume processing, look for the roof width, in this case the C positive, and increase this percentage to about 25%. That way we will have a smooth gradient between our smoke density and the edges. Okay, so in terms of the simulation or the actual motion of the smoke, I'm happy with this, but still this doesn't really look like a convincing wispy smoke. So what we're going to do next is work both with the shading and the post-processing of the volume. Let's work with the post-processing first. So here there's a nice trick. If you select your post-processing node and go to the volume post-process, you can activate the sharpen mode. Now, with the sharpen mode on, you can increase the smoke sharpening to about 250 or 300%. One other thing that you can do is change the mode to dilate and use negative values. In this case, we can reduce the smoke dilate amount. And notice how we're starting to get some wispy details and the feeling of smaller scale smoke. For now, let's try decreasing the noise scale. I will select the noise force and reduce the amplitude to about 4. And one more thing, I probably went too far with the dilate, so I'll go back to my volume processing and use -200. Let's go with this for now. The other half of the equation would be the shading. Select your shading, and first of all, let's change the color of the smoke So let's navigate to the smoke properties, click on the smoke color, and make a brighter shade of gray. Let's zoom in a bit. And now let's work with the shadowing. So I will scroll upward. Make sure to see your shadowing and scattering parameters. So first of all, if you take a look at the extinction color, it's relatively dark. I will change the extinction color to a lighter shade of gray. And one more thing I want to do is change the scattering value. I will increase the scattering value to about 50%. That way we're getting more light through the smoke. Okay, so one more thing I want to do is increase the resolution and also the frame rate of the simulation. Currently we have a very coarse result, but this is due to the voxel resolution. Usually to create wispy smoke, you will need quite some detail in your simulation. So let's select our simulation node. Let's go to the Domain tab, and let's upscale our simulation to at least twice. Let's click on Apply New Resolution. And now we're getting much more detail. Now, if the wispy smoke is moving fast, you may probably want to increase the substeps as well. So let's go to Time Control. Let's look for the time step, and let's increase the time step to about 90 Hertz. Let's reset the simulation and take a look at the result. Okay, so far so good. So what I'm going to do now is save the file, do a minor tweaks in the shader, and come back in a moment. Okay, so I've done some minor tweaks to the simulation and to the shader as well. I'll try to go through all of them. In any case, I will save this file for you to have with the rest of the tutorials project files. So first of all, what I did is change the color of the smoke a bit under the shading. One other very important thing I did in terms of the simulation, which made the simulation look larger, was under the simulation vorticity, I reduced the vorticity down to 0. This got completely rid of all the high frequency detail. Finally, I did increase the buoyancy and increased the smoke dissipation as well. For now, I will save the file and get ready to render our effects. We are finally ready to render our effects for the final composite. Now, there's a couple of things to consider before you start rendering your effects elements. First of all, the resolution of the image. In this case, our background plate or our background image is 248 pixels wide by 1640 pixels high. The other very important thing to consider is the frame rate at which the image sequence will play. For example, if you're rendering for video games, internet, or television, you might want to use 30 frames per second. But if you're rendering for films, for example, you will most probably use 24 frames per second. In this particular case, I will render at 30 frames per second. So let's dive back into Embergen. And one thing that you will always use, or at least I would recommend that you use, is a camera. Now, remember the scene node has an output where you can only connect a render node. And in the render input, you will have your camera input. So let's create a camera for our render node. Let's rename this camera render cam. And now let's define the render resolution. So if you remember correctly, we were using 2048 pixels wide by 1640 pixels high. Now, in terms of the timing, go to your simulation node, go to the time control, and take note of the timestep value. So remember we set this timestep to 90. This is important because 90 can be evenly divided by 30. If we were rendering this image sequence by 24 frames, for example, I would definitely use a number that can be evenly divided by 24. For example, 48 or 72. Okay, with this in mind, let's go back to our render node. And notice how by default the export mode is set to flipbook. This is more oriented to video game sprite creations. In our particular case, we're going to use these effects for video. So change the export mode to sequence. Now notice how the image size is not tied to the camera resolution. In this case, of course, we want them to match, but you can definitely render at a lower resolution or even at a different aspect ratio. So let's use the same settings that we used for the camera. In this case, 2048 pixels by 1640. Now that we've set the final image resolution, let's handle the time, which is controlled by two values, the number of frames and the frame stride. Usually your frame stride will be the number that you need to divide your frame steps to get your final frame rate. For example, in this case, we want to render at 30 frames per second. Since we're using a time step of 90, our frame stride should be 3 in this case. As another example, if we were using a time step of 60, our frame stride should be 2. And of course, the number of frames is the total number of frames we want to be rendered. Just a heads up, since Embergen starts counting from frame 0, if you want your frame sequence to finish in frame 100, for example, you would need to input 101. Or if you want your final frame sequence to finish in frame 300, you would input 301. Okay, so now that we've defined the image size and the frame rate, let's take a look into our image format and file name. So first of all, let's decide what kind of format we want for our image sequence. By default, Embergen will render a PNG image sequence. Have in mind that if your final input is for film or even television, you might want to render an EXR image sequence. For our particular purpose, the PNG file is okay. So first of all, let's define the directory where the image sequence will be saved. In my particular case, it's going to be under the project files, render, and I will create a folder for our battlefield shot. Inside the folder, I will create a new folder called Wispy Smoke. Okay, so I will select this folder to render in. As for the file name, I will call this Wispy Smoke _ and to create the number padding, you will use the hash symbol. In this case, I will select the preset from the list. As for the render settings, you usually want to render your alpha channel. We will talk about the shapes rendering with the fire exercise, and the rest of the parameters are fine as they are. So you want your volumes to be rendered, for example. If you have particles, you definitely want those to be rendered as well. Now, before we forget, let's set the view to render camera. And one very important thing for this particular effect, and also for the smoke column, I don't necessarily want to match the perspective of the back plate, because I'm going to use these elements as library elements that I can place anywhere on my composite. So what I'm going to do is center the camera on the simulation domain. In case of the wispy smoke, the light direction doesn't really matter that much because we don't have that much shading in the smoke anyway. Remember, this kind of elements that you can even reuse in other projects, you want to make them as generic as possible. So let's frame our bounding box in the center of our camera. Make sure we're encompassing the whole grid. And probably let's play a couple of frames just to make sure that our framing is working. And I think we can go with this. So I will stop the simulation, select my camera, and lock it. Perfect. So at this point, we are ready to render our frames. So I will save the file, pressing Ctrl S, click on my render node, and click on the Export Now button. Okay, so I stopped the render because I noticed that I forgot something very important, and I want to show you what that was. I loaded the frame sequence in Natron to be able to play it through. Now, if I press the A in Natron, I should be able to see the alpha channel. In this case, notice how the alpha channel is black. So I need to fix that and re-render the sequence. Again, I'll press A to see the RGB channels. And this is what we were looking at in the Embergen viewport. So let's dive back into Embergen and fix this issue. Okay, so we're back in Embergen. And one thing I'm going to do before we render is change the step size just to have a better performance both in real time and when rendering. In this particular case, I don't really think we need the 90 Hz. Let's select our simulation node, go to our time control, and change the time step to 60. Remember, since we're changing the time step, we also need to change the frame stride in the render node. So change the frame stride to 2. With this done, I want to show you how to better visualize your render frames. Now I want to show you the render view, which is an important tool when rendering your final sequences. So currently we're working on the scene view, which is the top left tab. Now, if you click to the right, you will find the render tab. This viewport will show you exactly what you're exporting in your final image sequence. Now, if you notice on the top right corner, you'll have a list of the components that you can display on this viewport. So let's click on Alpha Channel and let's click play. So notice this is what we should see on the alpha channel when the image is rendered. Now, if you take a look to the right of this channel list, you have a small icon with a warning that says no mapping for this capture type exists on the node. And what this is saying is in your render node, you're not exporting that alpha channel. You're only exporting the RGB components of the image. Now, we can add the alpha channels in two ways. First of all, you can click in Add Capture and select Alpha Channel. And now we have a destination called Alpha, and this is the extra channel that we need for our final render. I will delete the alpha channel for now, and I will show you another way to create this mapping. So here on the warning, you can click on the icon, and this will automatically create the alpha destination for you. Now we will be exporting our alpha channel as a separate image. Normally, you want to contain the alpha within the same image file where you have your RGB information. To do that, you can click on this icon called Show Hide Channels. Now that we're displaying the individual channels, you would connect the output of your alpha channel to the inputs of your rendered image. But notice we don't have an alpha channel displayed here. This is why we're only exporting the RGB channels. If you click here on this list, you will have your RGBA, and now you can connect the alpha channel output to the alpha channel input of your exported image. Finally, so Embergen doesn't attempt to export an additional image, you can right-click on this input and remove the links from the alpha channel. So at this point, we only have one destination, which is our main image with its RGB and alpha channels. So at this point, we are ready to export. So I will scroll down, click on Export Now, and I will be back with you with a final image sequence. Okay, so we now have our rendered wispy smoke. The render was extremely fast. It took about less than 2 minutes. But let's take a look if it's working as expected. So within Natron, if you press A on the viewport, you'll notice we now have the alpha channel, which is exactly what we needed. Now we will be able to comp this image over our background plate. With this done and knowing how to render our image sequences, let's go ahead and render our fire and our smoke column. Just one heads up, I did ended up rendering 1024 by 820 pixels. For some reason, the 2K rendering was crashing Embergen. In this particular case, that's fine because this is a stock element that I will use in a reduced scale in the final composite. I will definitely attempt to render our fire in 2K, but I will let you know if I have problems with that as well. So let's dive back into Embergen and continue our work. Okay, so we're back in Embergen and I opened our latest version of the barrel fire file. One thing I do remember I wanted to do was increase our bounds a little bit on the Z-axis so we don't have a clipping on the smoke or flames. So let's do that before I forget. So I will select my simulation node, go into the voxel count and increase the Z voxel amount to about 380. Press enter and hit apply new resolution. Now, if you remember, we did create a camera and a render node for this scene. So let's prepare the render parameters for us to generate our image sequence. So first of all, we want to change the export mode from flipbook to sequence. Now we need to define a directory where we want the files to land. So click on this folder. In my case, I already created a folder called Barrel Fire. So I will select the folder and click on Select Folder. And now let's add a name for our file. I want my file to be called Barrel Fire. And remember, we need to use a hash suffix in order to have a frame padding. In this case, it will be a 4-digit padding. So press enter. And let's take a look at the output of these files. So by default, we have this render viewport option, which will render everything that we see on the viewport. And if we click on the render tab, you will notice this is exactly how our image will be rendered once we click the export button. But in this case, we don't want the background plate to be exported because that will be composited later on in Natron or any other compositing software that you're comfortable with. So let's go to our mapping options. And first of all, let's delete this render viewport mapping. And I'm going to create one called Render All. Now, if we switch our view in the render viewport, let's select Render All. And you'll notice we don't see the background. So let's press play to have some fire going on. And this is exactly what we will have in our rendered image sequence. I will pause the simulation for a moment, and also I will save the file. Okay, now if you remember, by default, the alpha channel won't be exported. So let's also add a capture for the alpha channel. And remember, by default, Embergen will try to export the alpha channel in a separate image sequence, which is normally not what you want to do. Normally, you want the image to include the alpha channel. So I will click here on this button on top right called Show Hide Channels. And first of all, let's disconnect the alpha channel from this output. So I will right click on the link and click Remove Links. Now we need to add an alpha channel to our destination image. By default, it's only set to RGB. So let's change that to RGBA. And now we can connect our output of the alpha channel into the input of the outgoing image. One more thing I want to take care is the resolution of the final image. So let's check the camera just to make sure that we have the correct values. So remember, the display resolution of the camera and the resolution of the background plate is 2048 by 1640. So let's input these values onto our render properties. So width will be 2048, height will be 1640. For now, I will do a test with half resolution. So to do that, I can type divided by 2 and press enter. Same for the other values. I will divide this value by 2. And finally, one very important thing that I want to do is to matte out the cylinder or the collision object representing the barrel on the background. And let me show you what I mean. If I scroll down, you will notice we have an option called Shapes Rendering. Currently, it is set to Ignore. I can change this to Regular Lit, and now we will be able to see this object as we usually do in the viewport. Now, this is not exactly what I want because my background image already has this barrel on the picture. So what we want to do in this particular case is use this object as an occlusion object or as a matte or a mask to cover the fire. So let's change the shapes rendering to holdout. And this is perfect because we will see the flames, the smoke, but our collision object will serve as a holdout matte to cover what in our background image is the barrel. So let's go with this for now. Again, I'll save my file, click the Export Now button, and we'll be back in a moment. Okay, so I'm back in Natron with our rendered frames. The fire takes a few frames to build up, so I ended up rendering 400 frames. Which is fine. We can always edit the number of frames that we need for our final composite. Now, one final thing that I forgot to mention before I render, and I will go back to Embergen to show you, is here under the render parameters, I forgot to set the frame amount or the frame range. So in the number of frames, I ended up using 400, as I already mentioned, and on the frame stride, I used 2. So again, let's go into our simulation node, look at the time control, and since we're using a time step of 60, and the final frame rate of our composite will be 30 frames per second, I need to divide this by 2. Thus the frame stride value of 2. Okay, so with our fire element ready, let's open our smoke column file and render it for our final composite. Okay, so I'm back in Embergen and I opened the latest smoke column file. Now, for the smoke, we can take two different approaches. First of all, we could render the smoke as a generic stock element, and for that I would render the smoke in the center of the frame, and that would help us to composite the element in different places in our composite. And we could also reuse it in future work. The other approach would be to do a custom render with the precise camera angle. What I'm going to do in this tutorial is render this element with a specific camera for this particular composite, and then I will render a variation of the column as a custom element that I will position for our final composite. So before we render, I want to do two things. First of all, under my simulation, I will upscale the simulation by 2. This will yield a more detailed smoke. Secondly, I want to position the camera and place the smoke in its final position. For that, let's play a couple of frames and make sure you're under the render camera. And with your zoom and pan tools, place the smoke column wherever you want it to render. So in this case, I want this to be on the background, more or less like this. So let's save the file. I'll press Ctrl S and let's set up our render. Okay, so for our render element, select the render node. As usual, let's change the export mode to sequence. So remember, the camera resolution is 2048 by 1640, but I'm rendering with half this resolution currently. So go back to render, type 2048 divided by 2, and 1640 divided by 2. Now, before I forget, I will change the number of frames to 400 and the frame stride to 2. Let's create a directory to save the file. So I will click on the folder icon, right-click on the browser, and create a new folder called Smoke, column A. So let's copy this name, click on Select Folder, and paste the name here under the file name. Don't forget to add your hash suffix and press Enter. As for the channels that we want to render, we need our RGB and alpha channel as usual. So let's delete the default mapping, add a capture called Render All. This would be our RGB. And of course, add our alpha channel capture. Let's display the channels. And as usual, disconnect the alpha channel from the extra output. Add the alpha channel to our output image and connect it. And at this point, I believe we're ready to export. So as usual, I will save the file, pressing Ctrl S, click on Export Now, and we'll be back in a moment. Okay, so with all our effects elements rendered, we're ready to create our final composite. In this case, I will use Natron because it's a free software and it's almost identical in use as other high-end software like Nuke or Fusion. So let's start by reading in our files. So we can press R to create a read node. And first I will select the barrel fire, double click on the file. And here we have our read node. If we want to visualize this sequence in our viewport, just select the node and press 1 to connect it to the viewer. Now, if we press play, we should be able to see the fire in a moment. So remember, it takes a couple of frames for the fire to build up. Okay, so I will go back to frame 0. Now, one of the first things you want to do when creating your composite is determine the resolution and the frame range. And that can be done by pressing S on the node graph. This will open the properties for the project settings. The project format in this case has been inferred from the first image sequence that you imported, which is fine. So the resolution will be 1024 by 820 pixels. As for the frame range, let's start on frame 1 and go to frame 300, which is 10 seconds exactly. Now, one more very important thing that we need to check is our frames per second. Currently, the frame rate is set to 24, which is suitable for film, but in our case, we're going to render at 30 frames per second. So change this value and press Enter. Now let's make sure to save the file. So go to File, Save Project. In my case, I will create a folder called Comp. Dive inside and name this file Battlefield Comp version 01 and press Enter. Okay, so now it's time to load our different material. So let's try loading the background plate. Again, I will press the R key on my node graph and look for the images folder and load the Battlefield BG file. And remember, you should have available this file as well in your tutorials project files. Okay, so first thing, if you notice, this background plate is twice as large as my rendered images. So I will need to scale down this image or reformat it to match the rest of the material. So in the node graph, I will press the tab to open the menu list and type REF and look for the Reformat Transform node. Now, by default, the Reformat node will use the project resolution to resize the image. So let's connect this under the battlefield background. I can press Ctrl, click and drag until the node is connected under the background. So notice how the resolution is now matching the resolution of my FX element. And if you want to toggle the visibility of your two read nodes, you can select one of them, press 1, and then select the other and press 2. This way they are both connected to the viewer. And again, by pressing 1 and 2, you can toggle the visibility between these two read nodes. Okay, so now that we have our background ready, it's time to start merging our elements. Let's now composite the fire over the background image. So select the barrel fire read and press the M key. This is a shortcut to create a merge node. So notice how the fire will be connected to the A input, and we have a B input that we can connect to the reformat node. So think of the merge node as the A input will be composite over the B input. So let's select the merge node and press 1 to display this on the viewport. We can press play and take a look at the result of this composite. And right out of the bat, this is looking quite nice. So let's press stop, go back to our first frame, and now we need to resolve the issue of these initial empty frames. So I would say that the fire is fully formed around frame 120 or 140. This means that we would need to offset our sequence at least this amount of frames. So let's double click our read node. In this case, we can see that the image sequence has 399 frames. So we will be able to offset it a maximum of 99 frames. So let's do that. I will click and drag my read node just to give it some space. I will press the tab key to open the node menu. And if you start typing time, you will see the time offset option appear. So click on time offset and a time offset node will be created. So I can control click and drag to connect it to the read number 1. Now to offset the fire, we can change the time offset frame to -99 and press enter. So now we see the frames here. And although the fire is looking quite nice, I think we can enhance it a bit by adding a little bit of post-process glow. So let's try to do that now. I will stop the playback. I will select my time offset node and press the tab key. And this time I'm going to look for the glow node. So type glow and click on the glow filter. So a glow node will be created. And if you look at the controls within the properties window, you will be able to see the size of the glow, and you can increase the glow amount by increasing the gain. So let's do that. Let's exaggerate this value just to see what's happening. For example, you can type 20 and you'll start to notice the effect of this glow. So in my particular case, I want the effect to be quite subtle. So I think 4 was fine. And you can increase the reach of the glow by increasing the size. Let's try with a value of 5. So I'll go back to frame 1 and press play. So I think that this is definitely helping a lot. I'll just reduce the gain a tiny bit. I'll go with 2.5. And now we can continue adding the rest of our effects layers. Let's now bring in our wispy smoke. So I will click and drag my viewer just to make some space again. I will press the R key to create a read node. And this time I will look for my render folder. Inside I should have a battlefield folder. And here I will find the wispy smoke. So double click on this folder and then double click on the image sequence. Okay, so here we have our wispy smoke sequence. I will select the node and press the number 2 key to visualize this element in the viewport. And as I mentioned earlier, I'm going to transform this element and put it on top of my image and try to precisely match it with the barrel of the gun. So let's display the composite by selecting the merge node and pressing 1. And then with the read number 3 selected, I will press the M key to create a merge node. So make sure to connect the B input to the merge 1. And now to position my wispy smoke, I will create a transform. So with the node selected, I will press the T key, which is a keyboard shortcut to create the transform node. Let's now make sure to display the merge 2 node by selecting it and pressing 1. And if we now press play, we should be able to see the wispy smoke composited on the background image. Now let's try moving the smoke to the barrel. I will press Ctrl click on this icon to move it around and position it on the base of the smoke. So with your wheel mouse button, you can scroll in or scroll out to zoom in and out of the image. You can also press the middle mouse button to pan the image around. So what I'm going to do is select this transform gizmo, click and drag so it's positioned exactly on top of the barrel of the gun. Now, of course, the smoke is quite large. We can reduce the scale by changing the scale property to about 0.5. Perfect. Now, with the wispy smoke, there's a couple of things. First of all, it takes a few frames to build up, just as the fire did. And one other thing is I want to slowly fade out before the end of the frame range. So let's take care of the first issue, which is the buildup. To do that, I will use another time offset. So select your transform node, press tab, and type time offset. Click to create a node. And in this case, I will offset minus 50 frames. This should be enough to show the smoke on the first frame. So let's press play. I will probably reposition this more precisely. I will zoom in and click and drag on the transform gizmo. Perfect. Now to fade the smoke out, we can create a keyframe for the merge node. So notice how the merge node, if you double click on the node, has a mix parameter. So a value of 0 means the A input is not visible at all. So what I'm going to do is revert the value to 1, go to frame 150 and create a keyframe. I will right click on the mix parameter and click on the set key option. Now I will scroll forward to around 250, where we have our last frame of the smoke element, and change the mix amount to 0. So now we will have a gradual transition between 1 and 0 values. Okay, so let's frame our composite in the viewport. I can press the F key to do this. Go back to frame 1 and press play. Excellent. So this is looking quite good. I will save the file by pressing Ctrl S, and now I will continue adding our smoke columns. Okay, so now let's import our smoke column element. So remember, I did end up rendering one column smoke from the camera angle, and after that I rendered an additional smoke column centered on the screen. That way I can use that element as generic stock footage that I can position anywhere in my composite. Let's now load both of these elements. I will press R to create a read node. Look for smoke column A, double click on the folder, and then double click on the file. So let's take a look at this sequence. Select the node and press the 2 key, and then press play. This element is the one that is locked to the camera angle. So let's start by compositing this element. I will go to frame 1. And by the way, this element has 399 frames as well. We will need to offset it, just as we did with the fire. So let's click and drag this node. And with the node selected, press Tab and create a time offset node. So we need to offset this 99 frames. So in the time offset parameter, type -99. Now with the time offset selected, press M to create a merge node. And I will connect the B input to my merge number 2. Perfect. Now let's press play to see our result. And I would definitely like to offset the smoke column a bit. So I may need to reduce the overall amount of frames in the composite, but that's fine. Another option would be to render more frames for our effects elements. Okay, so although the smoke column is looking nice, we need to make it look as if it was behind these rocks. And to do that, we can create a mask or a roto shape. So let's do that now. I will select a frame where we can see the entire column, zoom in, and here beside the merge node, I will click on the node graph and press the O key, which is a shortcut to create a roto shape. Now, by default, the roto shape is set to draw Bezier curve, which you can see on this menu on the left. So select the roto shape node, press the 2 key to visualize this roto on the viewport. And if you click and drag, you'll notice that we can create a curve. Or if you simply click, you can create a straight line. We can also click on the first node that we created to close this shape. Now, apparently we're not drawing anything, but if you take a look at the properties, you'll see that the alpha channel is on. But in this case, I'm only interested in the alpha channel. So in the viewport, press the A key to look at the isolated alpha. Now, in an alpha channel, the white color will let the image show through the composite, and the black color will mask it out. So what we need to do now is a mask that will encompass the entirety of the smoke and just cut off the rock portion of the background. So let's do that now. Let's select the reformat node and press 1 to visualize this part of the composite. And remember, we're looking at the alpha channel. Let's change this to RGB. And now we could either modify this roto alpha, or altogether we can create a new one. So with the shape selected, you can press delete. You can also click and drag to select several nodes and delete them at the same time. Now let's go back to our draw mode, and we will be able to click and drag to start creating our roto shape. So let's zoom in. What I want to do is precisely go around the rock to mask out the lower part of the smoke. So I will create a couple of more nodes. You can always pan or zoom while you're drawing. In this case, I will make sure that the mask is drawn above the frame and come back around. And you can definitely loosely draw this shape since the background is defocused and the rock is quite organic and irregular. It doesn't have to be a perfect shape. So I think this should work. Let's first of all connect our roto shape to the merge node. So if you take a look at the merge node, it will have a mask input that we can connect to our roto shape. So select the merge number 3 and press 1. And you will notice how this roto is now masking off the lower part of the smoke, which is exactly what we want. Now, just one thing, if we zoom into the mask, you will notice that this edge is quite sharp. So what we're going to do now is feather the roto shape to make a smooth transition between the black and white colors. To feather out or smooth the edges of our mask, we can add a blur node. So make sure you have the roto shape selected and press the B key, which is a shortcut to create a blur node. Now, if you were to select the blur node and press the 2 key, you will see the result of this node displayed on the viewport. And we can press A to take a look at the alpha channel. So notice how the edge of the mask is quite sharp. So double click on the blur node and increase the size to make this edge transition much softer. So again, select your merge number 3 and press the A key with your cursor on top of the viewport. So notice how the transition between the smoke and the background is quite soft. At this point, what we can do is play with the blur size. For example, I might go lower for this. And also adjust the roto shape by double clicking on the roto node. And with your selection tool active, click and drag on the individual nodes to shift the mask. Something like this would do. So I will zoom out, close my roto shape properties, and take a look at the composite. And I think the roto shape is working fine. One other thing I want to do with the smoke element is defocus it, because if you take a look at the picture, especially on the background, we have some heavy defocus going on. So to defocus the smoke element, I will select the read node and again press the B key to create a blur. I will zoom into the image and slowly increase the blur size to try to match the defocus with the background. Something around 6 pixels. Perfect. So I will save the file. I'll press Ctrl S. And now let's incorporate our final element for the composite. Again, I will press the R key to create a read node. And this time I will look for the smoke plume A element. If you take a look at this element, we have almost 600 frames. And again, the column is building up. So what I'm going to do is add another time offset. I can even copy it from here, connect it to the read number 5, and take a look through the time offset. I will double click on the time offset node and increase the time offset to about -200. Or I can even go with -300. Let's try with this. Now, remember this is a generic element, so let's select both nodes, click and drag to make some space. And with the time offset node selected, press the M key to create another merge node. Connect the B input to the merge number 3 and make sure to display merge number 4. Now to reposition this element, I will select the time offset and press the T key to create a transform. And again, I will Control-click to offset the center, and then click and drag to reposition the element. In this case, I might need to scale it by about 1.5. Something like this. I will now create a roto shape for this smoke element. So I will select merge number 3 and press the 1 key to be able to visualize this part of the composite. I will zoom in and press the O key to create a roto shape. So I will make sure to connect the background to the merge 3. This way I will be able to draw the roto shape while visualizing the composite. So I will make some room here on the viewport and start creating my roto shape around the barrel. So let's click on one point here. And continue tracing the contour. Make sure to go around your frame and come back on the other side. Let's go with this. So let's isolate the roto node and take a look at the alpha channel. So I think this is working. So let's add a blur node. Remember, we want to feather out the edges. So we can increase the size of the blur. Let's try with 3 pixels. And now I will connect my roto shape to the merge number 4 mask. Let's display the RGB channels and take a look at the merge number 4. Okay, so the roto shape is working quite nicely. I just want to do a couple of things before I send my final render. So I will stop the playback, and the first thing I want to do is better match this second smoke element to the colors from the background smoke. So overall, the background smoke looks darker. And to fix this, I will select my smoke column on the screen right and press the G key. This will create a gray node that will allow me to change the gamma of this element. So if I gamma down the smoke column, I will start getting darker shadows. So of course it doesn't have to be identical, but at least we have to get it in the same ballpark. So I will decrease this value to around 0.84. And I think we can go with this. The other thing that I want to do is change the frame range for my shot. And to do that, I will go to the node graph and press the S key to display my project settings. So I will change the frame range to go from frame 1 to frame 200. And at this point, I think we're ready to create our final render. So I will select my merge number 4 and press the W key. This will create a write node that will allow us to save our file. So make sure you're in the render folder on the project files. And let's name our file battlefield_v01.mov because I want to create a QuickTime movie. And now you can click on the Save button. In the Properties window, you will have the properties for the output file. So first of all, I will change the codec to H.264. One more thing is I want to change the pre-multiply option to opaque because this video doesn't need an alpha channel. And finally, I will change the file output color space to sRGB. So at this point, you just need to click render to generate your file. Okay, so this is it, our final composite. And overall, this is looking quite nice. Nonetheless, I would strongly suggest that you continue practicing and trying different things, probably adding different elements or using your own background plate altogether. Overall, this has been a very fun tutorial, and I really hope this has been very useful for you. Stay tuned for Volume 2 of the Embergen tutorial, where we will take a look at more advanced features of Embergen and also an entire workflow of how to create your simulations in Embergen, export your VDBs into Houdini, and render them using Karma. For now, all I have left to do is say goodbye and thank you for looking into this tutorial.